Folks, welcome to the Landhammer stream. Hope you're having a good Saturday. Mine's going well so far. Already started labbing and going to continue to lab here. I figured, well, I might as well stream it. I was labbing earlier, but also kind of hanging out with the wife, taking care of a few chores. But we are on day 4 of the studycation. Technically, these are not vacation days, but it's a single long block of 6 days of study that I've carved out. So, and it's been going really well so far. I have an agenda here. Pull this up. So many desktops. All right, that's good though. So yeah, I've been working towards this goal of, network lessons that by November 30th, I want to have units, I call them units, 4, 5, and 6 done. So where I'm at currently is, I'm doing pretty well. So I've got all the way to, let's get a little music going, folks. Man, I don't have a chat window or anything going. Hope this music works for you. All right, yeah, it looks like it's coming through. Let me know if it's too loud or whatever. Open a chat window here. Don't really expect a lot of chatters right now. I understand it's Saturday morning and not my normal streaming time, but just in case, let's make sure the chat is alive and well, and it is. Good deal. So yeah, I'm working towards these goals, and my intention for Friday was to finish basically, man, this time has gone by fast. So Wednesday, Thursday, and Friday, I wanted to get all the way through MPLS, L3 VPN, encapsulation, and DMVPN, which I did. I had to rush DMVPN a little bit, but that's okay because that is not all new material for me. Like, I have covered already most of this. What was new was per tunnel QoS. So I did that lab late last night, while we're watching It, which is not a very good movie, by the way. I read the book years ago. Not years ago, a couple years ago. And I understand now they're making a second one, which I can understand why, because the book was so much... I mean, thematically, it was very similar to the book, which is a long book, by the way, but plot wise they definitely modified it for from the book, but I could see how they're going to tie it in and make a second one for sure. I don't necessarily recommend seeing it. It's pretty gross, and it's kind of but not gross in a thriller kind of way. It's more gross in a horror kind of way that was, I don't know. It's definitely horror. Anyway, moving on to networking stuff. So yeah, I got through those sections. Scramble, I basically read all day and took notes. If you didn't see it yesterday, I streamed about it. I created a new mind map. So we've got under notes, DMVPN. Mind map for this. So, I do take notes. I call myself not trying to take too many notes, but I do. Just in different formats that hopefully will be reusable and shareable and useful. So this has been around a while. This is in also my GitHub repo on ipv6 transition mechanisms. It has tunneling and NAT. So I'm going to turn down this volume on headphones because and I don't know if you can hear it or not. I watched the video yesterday and I didn't seem to be able to hear it. Let's see. And I don't know if you can hear it or not. Watched the video yesterday and seemed to be able to hear it. Let's see. Yeah, so I'm hearing it on the headphones, but I don't think you're hearing it. So let's try to adjust. Maybe it's the volume on OBS. I don't think you're hearing it, so let's try to adjust. Yes. And we got some biddies from Site of Origin. Thank you so much, my man. Appreciate it. Man, that is awesome. Showing support to the community. Site of Origin. Famous blogger. Very useful blogs, by the way, sir. Nice. Thank you for the good bits. When I think of good bits, I don't think of Twitch bits. I think of actually zeros and ones, but those are good bits too. Thanks so much, man. Yeah, hopefully it's gonna go well. I think it will. It's gone well. We are on schedule, in other words. So we're definitely on schedule. What I've got to get done today is I've got to get through. My goal today is to get through ipv6 tunneling. And I'd sort of taken like all day to do this. I don't know if it's going to take all day, really. But I really want to spend time on this because I got my behind handed to me in both written exams over this. Then tomorrow, I want to hit... Wow, that's... Yeah, I have... So I'm a little over halfway. We started day 4 of 6, so I think Unit 4 we're definitely going to knock out by the end of Studycation 2019. We'll just see how this paces out, right? But that's where I'm at. Let me check this volume again here real quick because it's always tough to find the right. I'm using my phone. Thanks so much, man. Yeah, hopefully it's gonna go. Barely audible. Oh wow, you can hear my fan in the background. I've got to nix that. So sorry about that, just a little sound adjustments here. So that should help. But yeah, I've been working on this chart here on IPv6 transition mechanisms. Just see how this sounds. Well, that fan was annoying. And now we have no music. There we go. That's why it was not on shuffle. And there is a good bit of delay I noticed too. Like it's a good 10 seconds or so, or maybe not 10 seconds, but well, you're my top bit donator now, Side of Origin. You go to the top of that slot for sure. Bear with me one more minute, folks. Sorry for the. I want to get this audio right. I want to get it good quality, so it's not garbage. Okay, that should be about right. All right, time to lab. So what I'm working on now is IPv6 tunneling, as I mentioned, and it's always been a challenge. So what I want to be sure to get right is some of the minor differences. Like I've already labbed 6 and 4. I finished that earlier today. And GRE I'd done yesterday. So just some of the differences noticed here. Of course, this is static. This is obviously, most of these are going to be protocol, IP protocol 41. Really, when you look at the Wireshark captures, you're generally getting oftentimes the same result, right? The differences here I'm seeing more with the IPv6 tunneling techniques are in the addressing and how it is configured and dealt with on the router itself. But in general, the result is often the same. It's a IPv6 packet, whether it be ping or whatever it is, just encapsulated inside of protocol 41, IPv4 protocol 41. So, which is reassuring. I'm trying to break this down to as simple as possible while catching any important detail. Like one thing I just read about was the MTU. So one advantage of 6 and 4 over GRE is the fact that GRE has a smaller MTU, or it has a bigger footprint, I should say. That's what I was working on now. That's what I was verifying. I'm also trying to make sure I get packet captures for all of these and adding it to the packet capture repo. So this is what I'm working on now, is the IPv6. We've got now GRE. That's not it. I'm also really working on my PCAPs to make sure that they just have exactly what is described in the title instead of a bunch of, non. All right, so this is the 6 and 4. So we have two essentially headers here, right? And does it tell me the length? When I select a header, will it tell me the header length? Oh yeah, it does right there. Header length is 20 bytes. Now, is that saying the next header? No. Not every header, I guess, is going to declare its length, so it should be like defined in the standard, right? Well, let's just compare that to GRE, which is here. Oh, because we've got an IPv4 header and a GRE header. Why can't I open these in two different windows? Darn it. All right, let's do this. Let's do a screenshot. That's fine. You won't let us open two windows. We can work around that. We have ways and means. All right, so we've got GRE here. So you have your normal IPv4 header. Then you have your IPv6 header. Directly next to that. I see why. Okay. So how long is this header right here? 4 bytes. Okay. Wow. All right. So that's 20 bytes. 4 bytes. It shows you down here. And the IPv6 header is 40 bytes. Which the IPv6 header is a variable length header, I believe. But aha, okay, so that's the difference. So MTU GRE got it. Okay. It's a chill song. I like that. Yeah, so you've got 40, 4, and 20. So I'm just going to put notes in that way, right? IPv4 header, 20 bytes. Plus IPv6 header. And we should probably do this. I should probably invert this 6 and 4. That's fine. So on this header, we have where to go. Yes, Technologies, where did you get those PCAPs? So I got those PCAPs right from this lab. And this is the lab from hell. So, well, it's got several names. I'm calling it a router collage. I'm calling it a I don't know, but it's got a lot of stuff in here. So right now, or the lab I did this morning was a 6 and 4 tunnel between these two routers here. And then the GRE tunnel was between this router and that router in the DMVPN tunnel. So yeah, made them myself. And they are available, by the way, if you're interested. This is my GitHub, and I upload everything into the GitHub repo called Packet Captures. So yeah, we've got, let me open that other screenshot. So basically, GRE is additional 4 bytes. So for the other MTU, I'm going to call this MTU considerations. We have ipv4 header. ipv6 header. Yeah, this ipv4 header plus a GRE. Interesting stuff. Okay. So yeah, that's our blog basically of the day is just, you know, finished DMVPN yesterday, doing ipv6 tunneling today. I need to do some flashcard review of DMVPN. So we could do a few of those now. This is running in Azure, by the way. That's how I can run 40 routers. So I'm up to 40 routers and 1 switch right now. Let's load our flashcards because I have not done this yet. And these are NecroCubes flashcards. His flashcard deck. But I want to browse and review DMVPN. Probably going to get a lot of these wrong. During the buildup of DMVPN Phase 2, spoke-to-spoke communications, how is bidirectional communication between the spokes established? So what happens on Phase 2 is NHRP request is sent to the hub by one spoke. The hub forwards that request to the destination spoke, and then the destination spoke replies to the source spoke. And it is routed through the hub initially. The first spoke sends an HTTP to the hub for the second spoke. The hub forwards requests to the second spoke, which then replies directly to the original. Second spoke then sends its own NHRP. Yes. I left that part out, but that was kind of assumed. The hub forwards requests to the first spoke. Yeah, the second spoke then sends its own NHRP resolution request, right? Yep, okay, good stuff. I did okay. For DMV, what is the next top IP address advertised by the hub? Advertised in NHRP, I assume. Yeah, what is the next hop? IP address advertised by the hub for a particular spoke. I guess that would be its own. I'm not sure what it means by advertise. Oh, I see what it's asking now. Okay, the spokes overlay IP. You're talking about when it sends, for example, when it forwards an NHRP request, what does it list as a IP for a spoke? Yeah, that makes sense. Sometimes I just struggle trying to grasp. That's one of my biggest struggles. You know, what exactly is it asking? For DMVPN Phase 3, what is the next hop IP address advertised by the hub for a particular spoke? Okay. So in this case, all right, so DMVPN Phase 3, and we send an NHRP request. One spoke sends it to the hub. Then the hub will forward that request to destination spoke. What is the next hop IP advertised by the hub for that spoke? In that case, it is going to be the same. Oh, okay. The hub's overlay address for spoke-to-spoke traffic. All right, let's look at that because I have a PCAP for that. Here's DMVPN Phase 3. Let's see, NHRP. Resolution request. Router 1 and router 5. So 1 is the hub. I believe, let's see, 169.254.100. That was, where did I do that lab? It would have been over here, 169.254. Really? Okay, my addressing might be wrong then. 169.254.0. That's just the loopback of this hub. The MBMA here is 10.255. Yeah, I've done this somewhere else. Where did I do that lab? Jeez Louise, maybe I changed the addresses here. I think that's what happened. All right, never mind. We'll be able to see. Who sent the traffic indication? 5. 5 is a hub. So 1 sends it to 5. And then 5 forwards it to 4. Okay, yeah, the source and the destination. Line information entry. Oh, yeah. I did this. I did not lab this. No, I had to have labbed it, but this was not. Was this phase 3? Let's just enable phase 3. Let's just do it. I've already got these routers open. Yeah, they're running right here. And I believe they are running phase 3 already. Show IP NHRP. Yeah, here we go. All right, show run interface. Show IP interface brief. Okay, it is running. IP NHRP redirect. And let's start with one of these. Yep, 10.255.254. Okay, so yeah, the overlay is 172.15. So let's do a PCAP on the hub. J02. We will shut the tunnel down and bring it back up. DMVPN tunnel. Or I'll just, let me see what tunnels I already have established on this spoke. I have a peer of 254 and 252. Okay, so let's hit ping 10.255. Actually, ping 172.15.249.250. Hey, there we go. All right. Resolution request. Okay, expert info. Malformed? All right. I think that might be fine. Yeah, NHRP resolution request. My NBMA IP, source, and the destination. So then the hub sends a traffic indication back to the source. Packet causing indication. Yeah. That's cool. I haven't looked at that detail. All right, and then it sends one to yeah, 250. So it actually sends a traffic indication to both, right? Then it needs to forward the request. But I'm not looking at the live. Hold on. Yeah, it sends an indication to both, and then it should. All right, let's look at this. I thought it sent another NHRP resolution request packet to the destination. It just sends an indication message. Traffic indications, source address type, sub-address type, source protocol, source NBMA address. So this is what it's sending over to router, the destination router. Source protocol, destination protocol. So that's really all it needs. Oh, but the source NBMA address is its own. Okay. That's true. Well, this has the hub's overlay address. For spoke to spoke, the hub sends an NHRP redirect to inform the source spoke of the destination spoke's NBMA address. Okay, let's look at that one. Let's look at that indication. That is his own NBMA address. The source protocol address is his own. Maybe that's what this is talking about. Okay. It's saying, it's replying back to the original router saying, hey, no, that's for this message only. Packet causing indication. All right, that's the original packet. Forward transit, NHS record extension, nothing really there. Basically, this is just saying a traffic indication is, hey, I got your message. I don't really see anything beyond that in here. I am replying to your NHRP traffic request. My source protocol address is this. Yours is this. Yeah, it's just an acknowledgement. This is the packet you sent. So, observing real life here, I can't really go along with I guess in theory you could say this, because this indication goes to the destination router. Let's see what's in here. I am sending you an indication message for this packet. And here is part of the packet, right? Yeah, I don't know about this. I don't know if I can sign off. I have found errors in here. Not many. Not very many. NetCube's got really good information, but the way I thought this worked is that a request was forwarded. Oh, here it is. Okay. Here is a resolution request, and it is on behalf of who? This is weird. Expert. Vendor extension ID. I don't care about that. Mandatory part. That's what we want. Okay, source NBMA address is this. Source protocol is this. The destination protocol IP is this. Responder address extension. Yeah, I don't see this in here. Unless this is talking about the client here. I need to go back to that lesson. DMVPN phase 3. Let me see if I can find actually a packet capture. There's one here from CloudShark. And it's using RIP, but it doesn't really matter. Okay, here we go. All right, so 1 is the hub, and 2 is trying to send to 3. So 2 sends a request to 1. I don't know how they're in this order, though. Anyway, 2 sends to 1. Here's a resolution reply. Yeah, 2 sends to 1. Then 1 forwards it to 3. This is what I expected to see. Yeah, I don't think that's completely accurate. Because it says here, all right, I'm the hub. I'm sending a request to router 3. The source request is router 2. It's the spoke, yeah. It's not my address, it's the spoke address. Source protocol address is this. So this part to me works basically just like phase 2. Except the main difference to me between phase 2 and phase 3, it's not how NHRP requests work. It's how the routing tables work and Ceph. This chain of packets looks exactly the same, except that there's an indication in phase 3 that says essentially, you know, hey, I got it. don't think this is an accurate. What is in for DMVPN Phase 3? What is the next hop IP address advertised by the hub for a particular spoke? Yeah, the indication is not saying. The hub's overlay address for spoke-to-spoke traffic. The hub sends an NHRP redirect of the destination spoke's NBMA address. So this is claiming that essentially in this conversation that the hub is letting the source spoke know the NBMA address of the destination spoke, and that is definitely not the case here. That is not what is happening. Incorrect. Yeah, the indication is just, hey, this is mine. This is the packet you sent me. I've got it. We are processing like it does use UDP, which is interesting. Yeah, there's nothing in here to indicate that. He acts just like he does in Phase 2. Here's a resolution reply. Now, let's see what the reply says as the... Yeah, this is his IP. The only thing that's really different is that the routing tables and like the initial relay of on the data plane. Oh, wait a second. All right, this is his reply. Now this has the hub's NBMA and the overlay address. Yeah, that's such a vague question though. All right, well, we know how it works. Okay, for which DMVPN phase is summarization allowed on the hub? That is allowed on 2 and 3. 1 and 3. This is allowed though. Summarization on the hub is not allowed because the next hop address cannot be modified. Hold on a second. Phase 2 does allow spoke to spoke. But the next hop address is always... Okay, yeah, that makes sense. The next hop address is always the hub because... yeah, we can't change it. Okay, the NVMe phase 1 does not establish spoke to spoke, right? And summarization is not an issue because all data plane traffic goes through the hub in phase 1. So yeah, we could send a default route or a summary route. Summarization on the hub is not allowed in DMVPN because the next hop address cannot be modified. Right. On the spokes routing table, we have to have all the destination IP addresses to route to the spokes, the other spokes. Yeah, I got that one wrong for sure. From a DMVPN spoke router, how do you configure reachability to the hub? You do a map. IP and HRP map, and then you map the overlay address to the NBMA address. Yeah, and you do next hop server as well. Our query message handled when both regular EIGRP and stub EIGRP routers exist on a common network segment. Both regular EIGRP and stub EIGRP routers exist on a common network segment, as in a DMVPN segment, right? In this case, for example, let's say you are the hub. So the non-stubs routers do not send queries to the stub routers, and the stub routers send queries to the non-stub routers. But on a network segment, they're not redirected. I know that. Like the essentially split horizon comes into play. Yeah, they're sent as unicast to non-stub routers. Or the RTP conditional receive feature is used to multicast query messages so that non-stub routers will not process them. Okay. This is common for hub and spoke routers. Oh, I need to look that up. RTP conditional. I want to cover whether the reply packet or multicast. Reply packets are sent in response to query packets. They're always unicasted to the originator of the query message and delivered reliably. Right, right. You have to basically, via the sequence number. To check it in live environment, you can debug and check the destination. Yeah, EIGRP uses 7 different packet types: hello, ACK, update, query, reply, stuck in active query, stuck in active reply. 5 out of 7 are acknowledged and 2 don't, hello and ACK, right? So query, update, reply use RTP and are reliable packets because EIGRP makes sure that they're reliably delivered and in proper order. Oh, here's Sarah. Okay, when a router. (224.0010). Our router 3 unicast reply back to router 2 and sets the ACK value field to 14, hence acknowledging the query. Right, you can see the packet is sent. What does it say here? Query messages are sent as unicast to non-stub routers. How to query handled by both regular and stub exists on a common network segment. Query messages sent as unicast, right? or the RTP conditional receive feature is used to multicast query messages by DMVPN or VPLS. Okay, what is the RTP conditional receive? Well, I like it whenever it's like a CCIE journey. They're usually answering the same questions I'm asking. ERJV's reliable transfer protocol. The manager delivery packets that it wishes delivered reliably. Update query reply, SI reply. Yes. Reliable multipass. This is Cisco's name for the method it used in RTP to ensure reliable order delivery. As mentioned above, it's very similar to TCP, non-zero sequence numbers used. The ERJV RTP conditional receive allows a list of lagging routers on a multi-access interface. Routers that have not act reliable multi-get one or more times to be tracked so they are sent unicast messages instead. This timeout is determined by the multicast flow timer and the interval between unicast transmissions by the retransmission timeout. Both of these are calculated based on the smooth round trip time, which is a measurement of time. Yes. In order to ensure these routers do not try to process both the unicast and multicast messages, the lagging router list is communicated in two specific TLVs, the sequence TLV and the next multicast sequence TLV. All routers receiving, man, this is complex. All routers receiving the packet examine the sequence to see if they are on the list. Any non-lagging routers will place themselves in conditional receive mode. Any router receiving the hello and finding itself in the TLV will not place themselves in CR mode. The sending router will then send the next multicast packet with the CR flag set. And those in CR mode will pick up this packet and use it as usual, then exit CR mode. Others not in CR mode will ignore it. Okay. So if you don't send it unicast and the hub sends its multicast and does not get all the acknowledgments that it's expecting, it has to create sort of a conditional acknowledgement table and slowly mark routers off the list until it gets a response from all the routers. Otherwise, it'll mark the neighbor down. Interesting. Okay. I just want to see what that looks like. Yeah, JRV conditional receive cap. Going out on a limb here that I'm gonna. Oh, here's the blog post. All right, I'm going to post both of these as links. This is probably covered more than network lessons under ERJRP, but yeah, this doesn't have. Not a lot of documentation on it, yeah, apparently. Let's do CloudShart. We recently learned that you can't actually do searches in CloudShart. It's not an extremely intuitive. Well, you can't do it. You have to do it using Google, right? Conditional RTP site cloudshark.org. Interesting. Yeah, it's a public. So we have 12.1 sending a hello, 12.2 sending hello, updates, and then we have hello acknowledgements. Yeah, there's nothing here. So this would be a reply, right? This would be a let's see, yeah, JRP reply site cloudshark.org. So we've got a query going out, right? And this is sent out multicast. We have a query reply sent unicast. Acknowledgement number. Oh, that's a hello ACK, and then we have a reply. Sequence 13, yeah. And he sends a hello ACK, okay. Yeah, JRP query. Here's some replies. Groovy music, I like it. I want to see an SIA. Yeah, JRP SIA reply. I'm going to have to start to move on in a minute just because I need to stay on schedule here. Yeah. The only way I'm going to get this is if I do it in the lab. Let me just read back through this one more time. So, JRP RTP conditional receive allows a list of lagging routers on a multi-access interface, i.e. routers that have not ACKed within a timeout window. Reliable multicast messages allows routers that have not ACKed reliable multicast messages one or more times to be tracked so that they are sent unicast messages instead. That makes a lot of sense. So if I have EIGRP running on the hub router and I have 1,000 spokes, right? We do need a little bit more of a sophisticated method to manage these queries. Ideally, I don't know, that is one of the challenges of DMVPN with EIGRP, right? But this timeout is determined by the multicast flow timer and the interval between unicast transmissions. So there's determined by two things. Because you want to know which ones have replied to the multicast query, right? This time I was determined by multicast flow timer and the interval between unicast transmissions by the retransmission timeout. In order to ensure that these routers do not try to process both the unicast and multicast messages, in other words, I already heard from you. I don't need, you know, you're not on the bad list, right? You've been a good boy. You're on the good boy list. Okay, don't worry about replying. The lagging router list is communicated in two specific TLVs, the sequence TLV and the next multicast sequence TLV. These are indicated in a hello packet. All routers receiving the packet examine the sequence TLV to see if they are on the list. Any non-lagging routers will place themselves in conditional receive mode Okay, I got it. I got it. Any router receiving the hello and find itself on the naughty list will not place themselves in CR mode. They're going to keep sending replies or attempting to send replies. The sending router will then send the next multicast packet with the CR flag set, and those in the CR mode will pick up this packet and use it as usual, then exit CR mode. Others not in the CR mode will ignore it. Okay. Yeah, I mean, it makes sense. Just takes a minute to understand it, right? Our query message handle both the edge or B. A query message sent as unicast to non-stub routers. Or the RTP conditional receive features used to multicast query messages so that non-stub routers will not process them. Okay. How do DMVPN perform encapsulation differently? EIGRP OTP does not use GRE. It uses OTP. DMVPN uses GRE, I believe. Yeah, DMVPN encapsulates both the data plane and control plane traffic inside multi-point GRE, generic routing encapsulation. Over-the-top protocol uses Lisp UDP encapsulation for the data plane, and control plane uses native EIGRP without encapsulation. Okay, good point. It's really more of a OTP question. How do you apply a QoS policy map to a DMVPN spoke? At the spoke, the command is IP NHRP policy. Oh man, I don't remember the command. I just did this last night. Only the output direction is supported. Now this is talking about the spoke. I believe this is what you do on the hub, not the spoke. I'll be able to verify that right now. That's the lab I did last night. For tunnel QoS. Yeah, so you create yeah, so this is done on the hub. You do, and in fact, well, let me check the hub the spoke configuration. Yeah, so this is incorrect. Well, at least the lab I did, it's nothing like this. VS. Oh, bouncy ball. Come on, bouncy ball. Do this to me. I don't know why it does that. It's only when I do Spotlight once in a while. So on the hub, you would do, well, spoke is what I'm looking at the moment. On the spoke, you do NHRP group. So interface tunnel 0. And that is all you do on the spoke. Now on the hub is where you define everything. So you've got your policy, well, you got your class map, policy map, service, policy. Well, that goes on the interface, right? So you got policy map. Then on the tunnel interface, it is NHRP. It's not IP, it's NHRP map group, whatever you named it, right? The service policy output. Yeah, that's how you do it. So I'm not sure. Let's see. Let's look at, so that's network lessons. Let's look at INE and double check, because this is saying IP NHRP group name. Assign the group to the policy map on the interface. Only the output direction is supported. Oh, how do you apply a QoS policy map to a DMVPN spoke? Well, granted, you still need the policy map on the hub, and you need to configure it on the interface. But for the spoke, you still need this command on the spoke. So, I don't know, it's just trying to do too much in one question, I think. I'm going to the INA workbook here. See if it has yeah, I don't think they have one. All right. I need to keep moving. Per tunnel QoS for DMVPN. Now, if you want, configure NH on a spoke. I guess you can on a spoke if you're doing for spoke to spoke. Maybe that's what it's referring to. You can do IP. Okay, you can do IP if you want. IP and HRP. All right, so I guess that would work if, but the question's not specific enough. Because what if you only want spoke to tunnel QoS? If you want spoke to spoke QoS, then yeah, you would need each one to have an NHRP group. That's correct. I guess that's accurate. But man, it's so vague. The question: how do you configure a basic ipv6 profile? All right, I need to move on. In fact, I'm going to take a break, folks. I'm going to grab some lunch, and then I'm going to come back, and we're going to continue working on IPv6 tunneling over IPv4. Yeah, we'll keep rocking on. So, hey, thank you, Tahigo. Tahigo in the house. Oh, sorry, folks. I've been so absorbed. I've been ignoring my chat. So, dude for him, good morning. Yeah, Tigo, clean up watching the background. I do that a lot, man. That's a great way to get through a lot of videos. Thanks so much, and good luck on your endeavors too with the on Twitter. So everybody, if you haven't seen this post yet, Tigo, give him a retweet. He's working on some cred in the community. So let me find it and post it here. But and let's see. I should have it here. Yeah, I retweeted. Here's the original. So copy link to tweet. Yeah, guys, go out there and retweet this. Give our man Tigo. Yeah, buddy, good bits all day long. This is how you get more good bits, by sending out good bits, because you get acknowledgments back with good bits, right? So, all right, folks, I will be back probably around 1, and we're going to keep on going. We're going to keep doing IPv6 tunneling. So, sending out good bits. We shall see you folks back here real soon on a LAN Tamer stream. And we're back. Had a good lunch. Gonna do some IPv6 tunneling this afternoon. So I may have to break at any time, just if I may have to help it here at the house here in a second. But yeah, we're just gonna go as we can and do some more IPv6 tunnel labs, get some little music going, little grooves. All right, so where I left off is doing some, I probably need to kind of reset the lab here. Let's log out, see what windows we have open. Yeah, Wireshark's running, okay. Lots of desktops. All right, so we've got the workbook over here. And the next one we're doing is we've done GRE. Uh, 624. Okay, we've done 6 and 4. We've done GRE. Now we're gonna do 624 tunneling. So I look forward to this one because I wanted to. Again, I'm doing a little chart here to compare. Just a little organization here. And last thing we worked out was the headers and the fact that IP that 6 and 4 has one less header than Jerry does. Obviously, Jerry has a 4-byte header. All right, so what we're going to do is move on to 6 to 4. And I'm not sure where I'm going to lab this yet. We'll see. Okay, so already we have a few disadvantages here. 6 to 4 is called auto tunnel IPv6 domains via IPv4 clouds. It is not static. but it does not support IGPs. That is a big disadvantage. So you have to use static routes or BGP, right? And there are two type of dynamic tunnels. Hopefully, I don't know if we're going to do both here. ISOTAP and 6-4. ISOTAP is intra-site automatic tunnel addressing, right? So we're going to work on auto 6-4s first. The reason it's dynamic is we don't have to configure the IPv4 address destination. But this essentially is going to be automatically derived, right? Probably need a new column for that. IPv4 address. Oh, the IPv4 endpoint. Derived from oh, this is the IPv4 destination. Yeah, endpoint. All right, we'll get into that in a minute here. And we know that this is a 2002, excuse me, uh, 2002:/16 is reserved for this purpose. Which is interesting. So 16 is the first 4 octets, or sorry, first 4 hextets. First 2 hextets. Let's go to our, I have this in the blueprint. Not that blueprint. And the drill sheet. Actually, no, it's in my notes under review IPv6 tunneling. No, it is in the drill sheet. Yeah, here we go. Interesting, I don't have called out. That is true. This is unicast global range, but inside of that range, so let's look at that. Convert to binary, yeah. So let's say, of course you cannot use my location. Oh, dude. Okay, you're gone. You're trying to get my location, man? Come on. It's the first hectet. 1, 2, 3, 4, 5, 6, 7, 8. Yeah. So the entire first hextet, as soon as you do 2003, so I'm trying to think of where the so that's 1, 2, 3, 4. Excuse me. 2, 3, 4, 5, 4, 8. Yeah, this is 16. So yeah, the entire 2 range is reserved for that purpose. So within the global, that leaves you 2000, 2001, and 2003, right? I want to make an exception here. Except. Yeah. Okay, now that we got that straight. Okay, we don't configure that before endpoint. Okay, so there's some more notes here about yeah, this is interesting. So I guess I hadn't really captured this before. So the IP address goes 2002:xxxx/48. Then you can subnet between 48 and 64. I need a new sheet here. So we have 1002/16 automatic 6 to 4. So 16 bits, and then we have (16 to 48). Then you have 48 to 64 is your subnet. There's a neat trick on Cisco routers Interesting. I didn't know about this little trick here. I saw this in another. Oh, this is cool. Okay, this could be a game changer here. So let's just figure out where we're going to put our tunnel. We need 3 routers. My thinking was earlier that I just want to do it between. Yeah, I was thinking right here I could do one. All right, so let's check on these routers. They're probably all interfaces are down. And we did no shut on those interfaces. That's the only disadvantage with so far that I've seen in Azure, and I don't think it's actually, I'm pretty sure it's not Azure. I think it's an image thing. That for some reason these images will often boot up without all the interfaces open. So we were running RIP over here. What I'm thinking we'll do is assign, let's see, we can assign one to router 6 and we assign one to router 7. Or just for grants, let's do one between router 6 and router 3. Yeah, let's do that. So I want to check all along the path, make sure all these interfaces are open. And we should still have routing as long as all the routing is still working. Yeah, we'll go ahead and open this one too. Yeah, we get ISIS running over here. That's cool. We're picking on the ISIS routers this afternoon. And let's make sure we have reachability between these areas. So we've got router 3. We really don't care about routers 1, 9, 8. Just routers 3 and 6, really, as long as we have reachability there, which we should, as long as I haven't broken anything. Show IP route. I believe I was redistributing. Oh, this is RIP. That's right. I never did configure the redistribution here. It's okay. We'll just do router 6 and 7. All right, let's make sure we have reachability here. Show IP interface brief. Ten 10.1.2.2 and 10.1.2. Okay. I lost these. I think I just did one large network for the whole thing, but they are connected point-to-point interfaces basically. GI02 ping 10.1.2. 10.1.2.2. Okay. Yeah. And what we need is probably we're going to use loopbacks. But here's the router trick. So let's say we go to router 6. And oh wow, with one command. So let's say it is Jazz01. Let me just double check something. 10.1.2.2. Yeah, Jazz02. Yeah. Okay, so what the trick is saying is that, so we're going to do this for just for grins for Jazz01. So we can do ipv6 general prefix, my prefix 6. What are the options here? Oh, nice. Wow, so I can calculate 6 to 4, 6RD, and I don't know what IPv prefix is, but, and let's say Jazz01, then show IPv6 do can't type. Check that out. Nice. Okay. That is a neat trick. Let's take a look at an actual. Now, I do need to know how to do this conversion though, and I'm pretty sure what you do. So let's take, for example, show interface Jazz01. So if this is the MAC address, we just have to convert these to hex, right? Interesting. That's one disadvantage of the Community Edition. 5000.006. I think that's a MAC. So what we would do is, these are decimal. Convert these. I have to convert them to binary, and then, well, you can use a calculator in the lab. Could do that. This is the MAC calculator, of course. Energy or work, length, power, pressure, speed, temperature, time. Interesting. They want programmer, be programmer edition. Oh, okay, interesting. Oh, nice. It shows a binary 16. Okay. So what if we do byte flip? Check this out. 10, 16. So this is to go the other way around. You can put in binary. How do I switch it? Byte flip. Interesting. I'm not sure how to do that on the Mac. convert to binary to hexadecimal. There are better web alternatives. Click show binary. This shows in your screenshot, and you click the bit you want to set. Oh my gosh, no way. Oh, I could do 10. Okay. Interesting. Ah, okay. All right. 5,000. 1388. Actually, that's not right. I don't think. It is. Yeah, that's not right. So we have to do each. So it's 5 A 6 A1. No, that's not it either. Man, I used to know this. Convert. Converting decimal has to divide the decimal number by 16. Integer. Well, this is a MAC address. Let's see if they have it here. Man, it's been a while. Oh, let's go the other way. So this says that my address will be alright, this A01 202. So A is 1001 A01. So let's try this. 2561. About 12 characters. That should represent, this represents a total of, oh, wait a second. I'm not doing a UEI 64 conversion here. What am I talking about? I'm doing a ipv4 conversion. Durr. All right, that makes a big difference. Jeez, 10.1.1.2. So 10 is a, well, 10 is in bits. It is 01. And actually 0001 8010. Okay. So that is 10. So to go from binary to hexadecimal, tens, 4, 1, 2, 3, 1. 842. No, star 01010. Yeah. Interesting. All right, man, it's hurt my brain here. All right, so this would be A01202. It's basically 0A01 0202, right? So 2 in hexadecimal is 2. O2 is 2. O2 is 2. O1 is 1. 10. There we go. 10, 1, 2, 2. All right. So let me try another interface here. So this would be, yeah, A0. All right, let's convert another one just for grins. Hey, Great Fox, how are you? What's up? Yeah, what am I working on? So I'm working on network lessons, 6-to-4 tunneling. So I just learned a cool little router trick that I'd seen it before, but I did not know what it was used for. So I'll show you in a second here. I don't know if that's a legit command or not. Yeah. So you do ipv6 general prefix my prefix 6-to-4, specify the interface, and it will do a conversion for you. And I was trying to remember how to do it manually, so I hadn't done that in a while. I had to work through that. Try ipv6 general prefix. Yeah, that's cool. So it says ipv6 my prefix acquired via 6-to-4. A01 10 1 2 2. Yeah, that's simple. That's simple. All right, I was making that a lot harder than I needed it to. I'd started out trying to convert the MAC address for some crazy reason. All right, so cool. Moving right along here. All right, so yeah, that is a neat trick. Now we're going to take a look at the actual configuration and where I want to line this up. Let's go ahead and update our topology here. Trying to use existing routers where I can instead of spawning new ones. So we're going to do a tunnel between router 6 and 7. And what I'm going to do is duplicate this. Yeah, no, I've enjoyed working with this. It's getting to be... It's not... Hey, we have a new follower. Oh, there's a new low latency toggle in Twitch. I didn't know that. That's cool. I just got a pop-up saying there's a low latency toggle. Yes, thank you for the follow, Great Fox 01. I appreciate that very much. So yeah, what happens is this is fine. Like I'm up to 40 routers in here. This is running out of Azure, 16 vCPUs and 64 gig of RAM. It's been working fine. I'm kind of doing it as an experiment to try to see how much it will take. And it's not really been a problem, like managing it. Just the only thing is when I have learned that whenever you do export your configs out of EVE-NG, that you really need to do them one at a time. I didn't even know you could do that, but you can export config because otherwise it goes through all of them. And learning to zoom is important. You can also lock the lab so that you don't screw it up, but yeah, let's back this out. Let's do -12 or -45 here, I think. Yeah. Maybe negative. That's about right. That's good enough. So this is going to be our new tunnel. With the community edition, you don't get as many like bells and whistles in terms of the lines and stuff. So this will be a 624 tunnel. I'm just going to keep building on this thing. One day I'm going to exact revenge on a study partner working with me, and I'm going to like reuse this lab. And that's why I'm calling it the lab from hell, because I'm also using really like ridiculous, you know, you may have seen this post on Twitter, like this, you're not supposed to use these IPs in production, but I am, just because I can. So we need to assign some we need to assign some ipv6 ranges. I'm using a different color for that too. I'm using this like purple color. Yeah, I'm getting ready for the written exam. Written exam is coming in 52 days, I think. So, how long have I been in networking? I've been in networking for, well, like full-time networking, I would say 5 years. Networking and IT in general and doing like support, 20. But I've done, you know, virtualization. I used to be a VCP, VMware Certified Professional. I've done a lot of IBM deployments, like I've done a lot of different things. A lot of server deployments, Active Directory, scripting, Exchange. I've done Exchange migrations, all sorts of things. Now I'm doing cloud. My full-time job right now is cloud engineering. But I came from a full-time network team. Now I'm doing just cloud engineering full-time, so it's fun stuff. I want to make that a little smaller. Yeah. Okay, so these will be our nice. Have my interview first Linux sysadmin job on Monday. Oh, best of luck. That's cool. I love Linux. I really do. Like, you know, it's really, interestingly enough, there's so much support for Linux in Azure. At our company, we use a lot of Linux as well. I mean, a lot of companies do, right? So that's great. What kind of, I'm curious what kind of work you would be, I guess you'll find out. Does it involve like package updates or package repositories and authentication? I'm just kind of curious of what job would be about. We've been kind of playing with, I meant to do send it back. Bring to front. No, let's do that. Yeah. Cool stuff, man. I love. I actually use, so my preferred distro for when I went cold turkey Linux. Like I said, the only way I'm going to learn this is just wipe my laptop, my work laptop. I could do that at the time. I was a consultant, and I wiped it and loaded I think I loaded Ubuntu to begin, maybe, but I ended up switching to Fedora. Fedora became my go-to, and I still love it. Became my go-to OS. And I ran that for the longest time. I still had a lot of applications I needed in Windows, but I would just, I loaded a VM. I actually imaged my Windows instance and then virtualized it. I made a virtual machine hard disk out of it and then uploaded it into VirtualBox. All right, because I started 2 years ago. I was studying a lot, but I'm sick of studying. I want to start something new, new job. I hope this works. I got LPIC1 cert. LPIC1, I'm not familiar with that. I did actually search. I did actually consider becoming a Linux sysadmin myself. LAN tamer could have been Linux tamer, to be honest. I really came close to pursuing that certification instead of Cisco at one time. Oh crap, what did I just do? Okay, 64 tunnel. We need to come up with correct addresses here. And we have a new follower. Hey, Kieran John M. Thank you for the follow. Appreciate the support. Enjoy the channel. Enjoy some networking. Packets are us here in LAN tamer stream. Yeah, so this is going to be 2002, and I actually should specify. You know what? We need to. I think we need to base this off of our loopback. I could be wrong. Let me check. Configure routing so we have reachability. Yeah. All right, we're not going to be able to use the loopbacks to. Oh, we need to configure global. So let's just pick a global address. The last one I used was 2001B. Let's do 2003 and FFFE, just because we're sick, disturb people. 7. I mean, that's like the last FFFE 6. All right, those are going to be our global addresses, so we can go ahead and configure those, I think. And we need to calculate the nice looking lab. Oh, thank you, Karen. I appreciate it. This is running out of, this is EVNG. I've got 40 routers booted and running out of Azure, single server in Azure. And it's running just fine. It runs faster than my local instance of. I have EVNG Professional on my Mac, but yeah, it runs really fast. So show ipv6. No, what was the command? Show ipv6 general prefix. Yeah. Okay, we haven't run it here yet, so ipv6 general prefix. I want to see if I can calculate this on my own, just for grins. So this interface is going to be. You know what, folks? I need to do a little window management here. So people will have an idea of what they can sort of follow along. Yeah. Yeah, so router 7. We're going to go off of interface GI02. Here in John, I'm currently using GNS3, want to use EVNG. currently studying for my CCNA. Failed initially in May by 100 points. No worries, man. I failed my CCNA too for when I took it the first time because I didn't take it seriously. Like, I thought it was like a VMware exam. And I learned very quickly that, and I did a retake like a week later because they allowed you to. I had a deal where I could retake for free. Failed that. So it took me 3 times to pass my CCNA, but the third time I took it serious, like I studied it like I should, and finally got it. So no worries, man. It teaches you, when you fail, it teaches you to become that associate level, right? You probably weren't before, and they force you to study more and more and become that, you know, that level that you're striving for. So you'll get there, I'm sure. Use it as drive, use it as fuel, right? All right, so I think I can convert this myself, but I want to learn the trick. 10.1.2.18. My problem was really stupid. I did a lot of layer 2 junk at work. Routing was really weak, so I thought. Turns out I got 97% of routing. Yeah, I know. I know that feeling. Trust me. I do know how that works. Let's zoom in just a hair or two here. So now you're going to learn more about switching. We're going to configure. I'm pretty confident in what this IP address should be, but spanning tree true. We got so many of those damn questions. Yeah, spanning tree is. I've spent weeks studying spanning tree, preparing for CCIE written, because yeah, you get into the deep topology change notifications, the spanning tree, optional features, loop guard, things like that. Multiple spanning tree protocol, rapid spanning tree protocol. Yeah, gotta know that stuff. Okay, ipv6 general prefix, my prefix, 6 to 4, GI02, and I'm going to say it's going to be A01, A0, no, 10.1 is going to be, yeah, A01, 2, A01, 2, 0, C12, shoot, hold on. 2, 1, 2. Yeah, A01212. Let's see. Do show ipv6 general prefix. A01212. That's right. Bit of a weird question. You don't have to answer, but how much does it cost per month to run your Azure server running EVE-NG? Hey, I don't mind. I get this question a lot. So I have through my job, I have $150 of credits every month that if I don't use them, I lose them. And I use them a lot for work-related testing and things like that. But this VM costs, now this is a big VM, one of the biggest that I'm allowed to use. And it is $1.69 a minute, but it's like, I mean, you see, you don't need one this big. You can run a smaller VM with EVE-NG for like 33 cents a minute. But, you know, you can do like a deal where you get a month free. So, yeah, so I would say 33 cents a minute is about what you would need. But again, it's good to have it for, well, a couple reasons. It's good to have a lab in Azure or Google Cloud, you know, or AWS. But you need to have a VM that is supports nested virtualization. Yeah, AWS, yeah, I think they all do something similar, right? So I know that AWS also now supports nested virtualization, but you just have to make sure you pick the right machine type. So when you Google, just Google AWS nested virtualization, and they'll tell you which machine sizes support it. Because yeah, you have to leverage the Intel chip virtualization features on the hosts. All right, so our IPv6 address then, our global address, will be interface GI02 IPv6 address 2000. Oh yeah. So we have to use, the global address has to be in this range. Oh no, it doesn't. That's for the loopback. Show IP interface brief. Okay, we're gonna do a new loopback. L76. FFFE:7/128. Hey, I have to go. See you next time when I'm a Linux admin. Nice stream. Hey, that's the spirit, man. You go out and get that job, and let us know how it goes. Good luck. Okay, we want to do the same on 6. I got a lab out of place here. Interface L66, IPv6 address. Okay, that is configured. All right, so we know what our prefix is going to be. And we configure a loopback, which is done. Now we need routing, which we have. We'll use the interfaces to build a tunnel. Since a tunnel is created automatically, we need to know the IPv6 equivalent. Right, we have that. This time we're going to use the IP addresses to build the tunnel. Okay, so let's start with router 7. Interface T76. IPv6 address is going to be 2002 A01 212. That's our /48 prefix. And we will give it a host address of 7/64. Ah, okay. Tunnel source is GI02. Tunnel mode IPv6 IP 6 to 4. Sweet. All right, that is done. Now let's go over here. and show ipv6 prefix. General prefix. Interface tunnel 0. IPv6 address is going to be what's above, which is 2002 colon A01 colon 202 colon 6 slash 128. Oh, slash 64. My bad. That's right. Oh, is it now? Oh, it changed it for me. Interesting. Do show run interface T66. Okay, what tunnel? 0. Ah, I don't want tunnel 0. No. Interface T66. IPv6 address. Tunnel source is GI01. Tunnel mode IPv6 IP 6 to 4. Booyah, we should be good. Oh, we could have used the loopback. We could have used the loopback, but that's okay. We might come back and change it. You know what? I'm going to go ahead and put it on here. Well, I'll change it. I'll change it in a minute. Hey folks, my little timer went off. That means I need to like stretch. So I'm going to take like a 5-minute break. I'll be right back. Don't go anywhere. We're just going to hit a nature break because we're going to keep going. I'm going to keep going all afternoon and evening as much as I can. As long as I take enough breaks, I'll have the energy. So I'll be right back. Alright, and we're back. Yeah, I think I need a command. I get asked a lot, and understandably so, about Azure. So I need to fix this too. Still getting some issues here. The lighting. I'm too picky sometimes with this stuff, I know. Go with defaults. Man, that's bright. This setup I have it can be a little high maintenance sometimes. I may have to go with the traditional bandana here. That's my solution for right now. Yeah, we're gonna do that so it doesn't distract me. Let me grab one. Okay, it's a little better. Defaults. Weird, I still have some. There we go. Yeah, I think I need a FAQ. ArcSam, how's it going? Welcome to the channel. So I have some commands, but people ask a lot about the Azure thing. So I think I want to create a command for that for Nightbot. I'll do that later. I'm gonna put this on my to-do list here. Then we'll get back to ipv6 and tunneling. We're going to be the Elon Musk of the internet and do more tunneling. ipv6 command for mentors in the house. Hey, mentors. I know you've had a lot going on. I appreciate you taking a minute out of your day to come hang out here in the stream. Hope you're having a good Saturday. Weather's nice. Some labbing. Yeah, we're doing some labbing, man. It's a part of my studycation, I call it. My 6 days of study. And this is an area I am particularly weak on, this ipv6 tunneling. So yeah, we're rocking some labs here, and we're using the monster lab at Azure. 40 routers. Okay, so what we've done is we have created our interfaces. We've created our tunnel interface. Now we have to be able to route in order to reach the other loopbacks. 40 routers, nice. You in the cloud? Yeah, man. Rocking out of Azure. And I need to check on this VM real quick. Anyway, so let's just check and see what the utilization is right now. Last time I checked, it got up to about 40% on boot up. So when I was booting up all the routers, it would spike. But it usually levels out. It's been leveling out around, average is 30 some odd percent. Went to Cisco UK headquarters 2 weeks ago. Their lab is insane there. I'll bet, man. I would love to have their lab. Nice. All right, so we need to create a route so that we know how to get there. And you know, I don't even think I have IPv6 routing on. So no, we don't. Oh, check it out. I don't think we even need it for tunneling. They're currently having power issues there because the improvement works at Heathrow. Interesting. What, are they expanding the Heathrow Airport? You will soon experience Cisco Labs, soon land. Once you get those numbers, yeah, baby. Once I get those numbers, we'll see some labs, all right. Isn't that right, mentors? Renovation of the terminals. Yeah, I'm here in Orlando, and they're adding a third terminal. And it is made, Orlando, everything is under construction in Orlando. I went there for some SD-WAN training. It was amazing. Yeah, man, was that Viptela by chance? Oh, Cisco ACI. Okay. Yeah, man, the automation is where it's at, for sure. All right, this is interesting. So I wonder if it's going to bark at me for creating an IPv6 route when I don't have IPv6 routing enabled. But otherwise, how will the tunnel know how to get to the other tunnel endpoint? IPv6 route 2003 FFFE 7. It's 128. This is an IPv6 static route, right? And we're going to use our, so we are, oh shoot. Do show run interface 266. Vitel was a flagship content though. Yeah, I'll bet. ACI was sort of a little bit of death by PowerPoint. I imagine that's something that's kind of hard to visualize or present visually. Has the opportunity to plan the circus meetup date yet land? Possibly this month. I've been MIA, so out of the loop. Man, I intended to do one for this week, but just got too busy. We need to do one for the holidays though, so we should target this upcoming week. Although, oh, did you get a hold of a show? Because he said he's going to be in Orlando this week. So we're actually planning a Meet Space meetup Tuesday night, if you're available. I know it's a drive, man. I understand. He mentioned on Discord. Not sure if you saw that, but I know you've been out of pocket, and understandably so. Okay, we're gonna create a route here. 2003 FFFE 7/128 via 2002 A01 202 6. Oh, through the other tunnel interface, right? (2002) A01 212.7. IPv6 route 2002 A01. Oh, I used the wrong one. Yeah, 3 FF E colon 6 via 2 A01 202 6. Yeah, Harry's coming. We'll try to meet up with you guys if I can balance some family life going on lately. Yeah, I understand, man. I understand. The routers will have to do recursive routing to find an entry. Oh, there's another route. There's another route. ipv6 route 2 /16 tunnel 76. ipv6 route 72 /16 tunnel 66. So here we go. Ping 2003 FFF E colon 6 source L it worked. And I was starting to doubt that it would actually work. Ping. We want to ping 2003 FFFE colon 6/128 source L76. Ping source what is it like? What is it not like there? All right, wait a second. What is the difference between that and this router? Ping. Oh, it's because I use the, okay, I got it. I don't need the prefix on here. Boom. Mentors, this Narvik topology does not look like an INE lab. You are correct, mentors. So this is what I call the lab from hell. Look at these IP addresses I'm using here. 169.254, 169.254, 255.255/32. Yeah, it's kind of crazy, but it works. And this is me doing mainly networklessons.com labs, small labs. And just each time I do a lab, I pretty much add on to it. So instead of starting a new, you know, I just add. I know, it's crazy. I like that. Got your prefix? That needs to be, remember the Got Milk shirts? Got prefix? Okay, so that works. So let me just get my head wrapped around this real quick. Show ipv6 route. Now this is interesting because show run, and we need to change the music here. I've already looped this once. This is the free YouTube music, nothing special here. Show run include routing. Interesting. So IPv6 routing is off. Nemo, network mobility. Hey, we found Nemo. Am I crazy, or isn't there an IPv6 routing command? Like I just did a lab. Oh, right. Thank you, Kieran. IPv6 unicast. What are all of the IPv6 options? Yeah, that's exactly what I meant. Thank you, John. See, I don't have that enabled, right? But yeah, we're able to add a static route. A unicast route. Ceph CGA, certified generated address. Interesting. DHCP relay. Low set, general prefix, hop limit, ICMP, inspect. LDAP, local. Multicast forwarding information base. Multicast listener discovery, mobile. There are two mobiles. Is that just for emphasis, or I'm going to screenshot that. It's going to be interesting. Like, why is that listed twice? Multicast and multicast routing, right? MUX. I'm assuming it's multiplexing. Yeah, IP multiplex configuration, NAT, neighbor discovery, neighbor, OSPF, PIM, port map, prefix list, radius, RIP, route, router, RSVP, source route. SPD, selected packet discard. Interesting. Never heard of that. TACAX, traffic, unicast routing, WCCP. Okay. So IPv6 unicast routing. However, if I do show run all, I should see that. Doesn't it just not forward the traffic on if unicast routing isn't enabled? Could be. I think it's different, right? Because the Cisco router image has IP routing enabled by default. You can say no IP routing, right? But so that's IPv4 routing is enabled by default, and IPv6 routing is disabled by default, I believe. And unicast. Show run include unicast. Interesting, it doesn't show that. Okay, this parser mess is this is messing with me a little bit. Okay, that's fine. So I understand. I did a no IPv6 unicast routing, and that is the default. So it doesn't, even when I do a show run all, show parser. No, that's not what I want. Show run all. After looking that up, I'm wrong. Doesn't it just forward the... Okay, look at all this stuff. Is this an alphabetical? No, it's not. I could probably do some sort of sort, but it doesn't even show it to me here. No IPv6 neighbor discovery router advertisement solicited unicast. Interesting. I did not know that was a default. I thought that was not the default. Oh, here's some more. Oh, let's do this. Show run all. Include IPv6. Look, no IPv6 Ceph is enabled by default. Yeah, it does not show the routing command, although I'll show you where I have it. So I'm running RIP over here, IPv6 RIP, in another part of the lab already. Last night when I was doing DMVPN, maybe it wasn't there. Maybe it was using any OSPF v3. Not in this lab. Not yet. Okay, it wasn't here. Where was it? I'll bet. Oh, it was over here, I think. Let's check on this router. Yeah, RIP. I think RIP is running right here. Yes, it is. There it is. IPv6 unicast routing. So it's interesting, the parser, if you do a show run all, and the no form of the command is in use, which is the default, it does not show that to you in the output. What's with Sunglass CCIE? Muse, Xbox Live, XBL maybe? Good question. Yeah, it's we're going Casey Neistat style here. So I don't know if you follow Casey Neistat, but it provides a better viewer experience, like, you know, not tracking my eyeballs necessarily. He actually did a video on this because he gets asked this a lot as well. Yeah, why do I always wear sunglasses? You have to jump to... By the way, folks, if you don't follow Casey Neistat, he's a great vlogger, man. He's like a vlogger extraordinaire and entertaining, like very entertaining. You should create a bandana with the network design on. Yes, John, Kieran, I did do that actually. Started to do that. Set up a store and create my own bandana design, but they rejected my artwork, so I got to work on that a little bit. I'm here to watch the lab stuff. Don't worry, man. I suck at IPv6. Yeah, no problem. I'm I've got so much to learn as well on IPv6, but I love it. Like, I used to dread working on anything related to IPv6, and everything changed for me when I switched my home network over to IPv6 by default. So, and that, for some reason, that just made me like really start to enjoy it. I started paying more attention to it, and now I'm a huge fan of IPv6. It's like a complete 180 for me. Like, I love any opportunity to work on it. And I've become that nerd, right, who loves IPv6. There's a podcast on packet pushers now dedicated to IPv6. It's called IPv6 Buzz. Yeah, definitely check it out. It's got some good stuff in there. And when I learned that about a quarter of all internet traffic now is IPv6. So my ISP in the UK doesn't support IPv6, so I don't want to have to transition at the edge. Yeah, I understand, man. I was surprised. I just tried it one day. I looked at my gateway router, which is Spectrum. I noticed they already had it on there. All I had to do really was just change my default DNS to be an IPv6 support quadruple A records, and boom. That's all she wrote. And it's awesome. It's fun. So yeah, it's interesting thing about the parser. I don't care a whole lot. It's good to know in case you just have to know you can't rely on show run, to see unicast routing. And the other thing, the reason I went down this road is because I know I've already had to turn it on whenever I'm running a routing protocol, but it appears that it's not required when you're using static routing or a tunneling scheme, which is interesting. I wonder if Ceph is on then by default. All right, lost my window. Help. Window hell. All right, too many. There we go. So I wonder if now that I've turned on unicast routing, oh, we have a new sub. Thank you so much for the support. Kieran John M, really appreciate it, man. Enjoy your emote, enjoy the good bits, and let's get some good bits in the chat for the support from Kieran John. So appreciate it. It always it helps keep me going when I see people on the stream and who are involved and asking questions and making me second guess sometimes is good. It's actually been very helpful, especially when doing labs. I had an experience on here one time when I was first learning MPLS, and I was struggling with a particular lab, and I had someone on here who used to work at TAC. He's already a CCIE, and he was like helping me get through the lab. I was like, yes, it's awesome. So yeah, what's interesting is here. No way, Holly. Yeah, it has happened before, and now I'm friends with a person, and it's actually Dimitri Fiegel. He has his own Twitch channel as well. By the way, if you are looking for content, I'm not the only networking Twitch streamer. There's a link here of people that you can follow on Twitch. I saw you advertise this on Instagram last year. I thought I'd finally come and check it out. I usually stick to Router Gods. Hey, yeah, I'm in Router Gods as well, and I'm just not as active as I would like to be. But yeah, the Router Gods is awesome. It really is awesome as well. There's a lot of good stuff in there. So yeah, we've got, I find it interesting that, so if we look at, so I have a static route for IPv6, and I have a tunnel interface, and I have a loopback that is IPv6, but IPv6 Unicast routing has not been enabled. And ipv6 Ceph has not been enabled. Does that mean that Ceph is not used here? Yeah, see, why would I not want to run ipv6 Ceph if I'm using... Why would I want the processor to do a lookup? I know this is stateless, but still, I don't know, that's just not making... Anyway, I don't want to get in a rabbit hole here. I want to keep moving. So our pings work, our tunnel works, and I'm just trying to kind of get my head around. Let's do some PCAPs here. And I think the next task on my list is to finish working on this transition mechanism spreadsheet, right? So we need a few little details here still on automatic 6-to-4 tunneling. So we know it's not static, it's dynamic. We cannot run IGPs over it, which is a big disadvantage. It is stateless. Pretty sure it's protocol 41. Let's do a PCAP here. Kieran John M. I've come up with a plan for my CCIE journey. I'd like to be CCNP by 2021, then CCIE by 25-20. That is awesome, Kieran. Man, I love seeing people come up with a plan because it's not going to happen on its own. And I don't know about you, but I work pretty well off of a self-imposed sort of deadline. So yeah, that's great. Good for you. Keep it. I'm assuming a route switch on that. Route switch is definitely a good springboard for sure. I don't know if y'all follow. There's someone who I really love their hashtag CCIEby30.com. She has some great content too. I work as network engineer. Hey, Thug Muffin. I work as a network engineer at a big SaaS company. We have a spine leaf architecture. Cool, nice. Software as a service company. So, yeah, good to have you here. Enjoy a little networking. So we need to keep, let's do a PCAP here, and I want a PCAP on router 7, Jazz 02. Definitely, yeah, route switch or security. We have 367 work environment. Luckily, I started straight in the projects team and not the NOC, so I've got a good group of peers to help me too. Kieran, that's okay. You know, NOC is good too, depending on which level, because you can actually... I have worked at the different, you know, I've worked projects, I've worked operations. Over time, it's good to get some exposure to all aspects of it, right? 18, nice, Kieran John. Yeah, 26 here. I'm looking to see if I add your 2 ages, if that is close to mine, and it is pretty close. So yeah, the younger you start, the better. That's great. That's admirable. I let a lot of stuff sidetrack me in my career, so I would have liked to be much younger and obtain the CCIE, but it's never too late to start, I say. All right, that capture, where did it go? Did it start? Yeah. I thought I typed, did I type in the password? I did. All right, where'd you go? Where did you go? Oh, Def, I don't know everybody, but in the UK I know a lot of NOC guys who get a lot of, you know what, and people busting their... Yeah, it is high stress, but some people say, like, to get really advanced in the Cisco organization, for example, that you need to have done time intact, right? And I can see the argument there. Yeah, my stuff didn't launch here, so let's start it over. Not sure why that occurred. 02. There we go. Okay, we need to enter the password. Okay, I just had closed it subconsciously. I think that's what happened. I'm constantly closing windows because I'm so hyper aware of opening too many windows that I generally close some of them too soon or without really paying close attention. So just first world problems, right? For sure, yeah. All right, show ipv6 interface brief. All right, so we're gonna ping the remote tunnel again, which is, well, actually the remote loopback 6, source tunnel 76. Okay, so we should have some traffic. Let's look at our encapsulation. Here we go. I'm saving a collection, by the way, folks, of all these PCAPs. So my collection is growing. They're out there on the GitHub. If you're ever interested in following along or checking them out or contributing, feel free to ping me if you'd like to contribute some good ones. But here we go. So this is, let's mark this packet and that packet, which is a response. And let's look at our encapsulation. So we have our standard IPv4. Somewhere it was showing me the header side. Yeah. Header length is 20, normal, right? And then we have our IPv6 header. So this type, what we're expecting is type 41, protocol 41. Yep. And the source address is the tunnel. Yep, it is protocol 41 for sure. So the source is the tunnel's address, and the destination is a global loopback address. And the header size should be 40. Somewhere I thought it told me here in Wireshark. Where am I missing that? Like usually if I hold this over, like it'll show me information down here sometimes. Let me reopen it. I think when I first opened it, yep, definitely 41. Yeah, there we go. So it's when I select information here. Okay. It's a little different, I think, on the Windows version. Oh, that's just feedback on the content. Yeah, how do I see how many bytes this header is? See, the header length for IPv4 is actually part of, I mean, it should be 20. It should be 20 bytes, right? I mean, aren't all headers in IPv6 20 bytes with the with optional extension headers? I want to say that's true, but I don't trust myself on a lot of these things. Try expanding that second field. This one, the traffic class. Yeah, that's just... within the ipv6 section, yeah, there's just... So they'll tell you the next header. Source, destination. Oh, this is interesting. Now, is this derived? Source, destination. And this is in brackets. All right, we need to break this down, folks. I need to know. Inquiring minds. IPv6 packet. Hey, good old Wikipedia. I've actually found Wikipedia. Have y'all found the same? That it's usually pretty informative in terms of networking. It used to not be. Years ago, there was a lot of garbage in here, but okay, yeah, extension headers. Fixed header. I thought so. The fixed header, the size of 40 octets, 320 bits. Okay, 40 octets, so 40 bytes, not 20, 40. Version, 4 bits, traffic class, flow label, payload length, next header, hop limit, source address, destination address. Well, yeah, it would have to be larger than the IPv4, so this chart is off. Let's correct our chart. I have a chart here. I know it's hard to see, folks. Let me zoom this. Let me zoom in. I'm still learning this version of, I just upgraded Office on the Mac here. Okay, I've got it right. Yeah, 40. Now, what I find interesting here still, so this is the same. Between manual 6N4 and 624, tunneling, pretty much the same on the header sizes, right? But now where in the heck did Wireshark go? Does it? Oh yeah. Let's export this. We can go ahead and stop and export this. Mark packets only. This will be added to our collection. This is IPv6 tunneling 6 to 4. Cancel. Let's just close. All right, yeah, what I find interesting is what's in braces, brackets, I can never remember, even though like I work out of JSON files all day long. Down here, I think that's interpretive, right? From Wireshark. Yeah, that's interpretive information, I believe, because if we look at the actual bits down here, so all right, we have payload length. What is your day job, Lan? Well, I transitioned a few months ago from a full-time network team to a cloud engineering team. So now I'm working, doing a lot of templating in Azure, working on a lot of automation. I actually did a vlog about, people were asking, should I do cloud or CCIE? I did a vlog about this yesterday, I believe, published it on my YouTube page. So yeah, I'm really enjoying it. All right, so yeah, if we look at these, so we've got payload length. SP World is the best. You mean service provider? As long as you're not first line. You know, I've often contemplated, like, if I was to go for another CCIE after routed switch, what would it be? And service provider fascinates me the most, I think. So source 2002 0A 01 0212. All right, hold on a second now. Why is this? So 0212. Right, all these zeros, right? That's 128 bits is a source address. Then we have the destination address. All right, the next field is 8000. And it jumped. All right, hold on. I want to know what's, like, what is happening here, right? So it's actually telling me, is that derivative though? It is derivative. Okay, so this is just interpretive. Wait a second. Source. What about data center? Yeah, data center interests me too, but I don't know. I guess I've actually taken some classes on data center, some intermediate, like CCNP level data center classes. Never went for the cert or anything. And I enjoy it, don't get me wrong. I don't know, just to me, it seems like there's more future, for me anyway, there would be more of a future in, because I've already sort of transitioned to more of cloud data center, sort of. So it'd either be that or route switch is so very enterprise, right? But yet service provider, I mean, there's a long future in that for sure, and that's going to become even more and more critical. I don't know. Plus the technologies like the QoS fascinates me, and I'm fascinated by underlays and overlays and VPNs. It just seems like I'm fascinated by ISIS, as old as it is, right? So yeah, this is all interpretive here. I need to look that up. Let's look up how to interpret some of these symbols. Wireshark symbol. The packet list pane. That's what I'm talking about. See, I've never really paid much attention to this, but what is this? Oh, this is their own doc. This is their own documentation. Filter toolbar. Generated fields. Wireshark itself will generate additional protocol information which isn't present in the captured data. That's what I want to confirm. This information is enclosed in square brackets. Yes. Generate information includes response times, TCP analysis, right. If Wireshark touches to another packet, it will generate a link to that packet. Links are underlined and displayed in blue. All right. Yeah, need very strong route switch skills to be good at service provider. DC is more of a niche, and most value-added DC services are overlaid over existing SP-WAN. Very true. Okay, so these are interpretive, and yeah, I'm noticing now sort of more of this formatting of Wireshark that I've always sort of taken for granted. Like, I guess in my head, I never really stopped to think about it. I just assumed that this was the case, like header checksum status unverified. All right, so 40 bytes in length, and it's just a standard the only real way that we would know this is tunneled is two ways. One is that we have both an IPv4 and an IPv6 header, and that the IPv4 header has protocol type 41, which is obvious, right? It's a IPv6. 41 means you're going to give an IPv6 header. But the only way we know it's automatic would be from the destination address, right? Because it's in 2003:16. iOS XR is fun. Yeah, in our Discord channel, there's a lot of people who talk about. We have a service provider. In our Discord server, we have a service provider channel, and generally, some of the discussion tends to be around iOS XR for sure. All right, cool. So that's what we expect. Let's continue filling out our sheet here. So that's the header. IPv4 destination is derived from the IPv6 destination. So I think what that means, that's not the tunnel destination, but the IPv4 traffic. That's the traffic IPv4 destination address for the data plane. This is manual. This is derived from the IPv6 destination, and I think what that means is, so show run interface T76 makes my customers lose their mind though. What's that, iOS XR? Yeah. Here, John, I'm taking a wild guess at saying you work at Capita. Okay, I guess what this means though is the tunnel destination. All right, so let's do IPv4 tunnel destination. Static add to static add, and it is the static add for remote destination. I guess that's the best way to word that. Not configured, derived. Yeah, so in other words, if I'm just looking at this tunnel configuration, I have my IP address. Because I configured the mode as 6 to 4, that means I don't need a tunnel destination address. The destination will be derived from the traffic coming into the tunnel. No, how one of my friends from work used to work for them before joining this company. Cool cat. Yeah, I like all the UK folks. It's great. I know. What time is it in the UK right now? I guess it depends. Depends on your time zone. So here's a question. 8:52. All right. So you are 5 hours ahead. So this is interesting. When we look at the manual tunnel, and that's one of the big things for the CCI route switch written, right, is Knowing the difference, knowing how these are different from each other, right? The configuration for that, actually I have it here. So that's a cool thing about having a big lab and having all this stuff running, is you can always reference it real time. Show run interface T116, if you can remember where you put it, that is. Yeah, see, I have to have a tunnel destination here. This is what I've always wanted to be able to do right here. See, another interesting thing, folks, is that the ipv6 enable is not turned on here. I had to do that here, I think. Yeah, because that's how I form adjacencies with RIP. Tunnel source. And this has a tunnel destination, which obviously is a limitation, right? It's statically assigned. Okay. Let's look at the show interface tunnel. There we go. IPv tunnel protocol transport IPv6 6 to 4. Set of tunnels with source one member includes iterators on interface. All right, folks, I need to take a quick break. Got a family here member who needs my help for just a moment, but I will be right back. Don't go anywhere. Thanks again for all the support, folks. We're going to put up our break screen here, and I'll be right back. Okay, we're back. Thank you for the patience, folks. I had to step away. My wife came back from grocery shopping and needed some help unloading, and she's been very supportive, man. So supportive of me doing all this preparation for my exam. My exam is December 31st, New Year's Eve. So on New Year's, man, I'm going to be drinking one way or the other. Either celebration or tears after a third fail. So anyway, yeah, I had to help her out. Well, we are back to this. So we're back to filling out really differences in our IPv6 transition mechanisms. The tunnel link local address format. Well, see, that's the thing. Like, I don't even see one here. And I guess, to be honest, you don't need one if you're not going to if routing protocols are not supported. I wonder why that is. No, we did have ipv6 interface, but that was for the loopback. No, the tunnel interface does have one, and the loopback has one. Yeah, I think any interface is active on IPv6. You're going to have a link local address. So we have one here. I don't think it's important, maybe. We did not see it in the packet capture. Yeah, it's interesting. I can see why this 6-to-4 has such potential, for use, but yet it has some pretty severe limitations. This is the same. Tunnel IPv4 address. Is that the same as what I have back here for destination? Trying to figure out what I meant by that heading. Same as tunnel source. Okay, so this is talking about does the tunnel have an IP address itself? Show IPv interface brief. Yeah, it's unassigned, but over here. Did we have one? Yeah, unassigned. Yeah, none. I'm just going to note that there. For tunnel address assignment is none. None. Did we have it in GRE? That's cool, because you know what I'm going to end up with is I'm going to have all these tunnels running in my topology here. This one has one, but it's not because of IPv6 GRE. It's just because, yeah, I think you have to have it for a GRE tunnel. Let me double check that though. Yeah, I think you do have to have it because you're tunneling over GRE. Let's. I guess what I'm trying to say with that field is what is the source and what is the destination IPv4 address? That's really what I should have here. So what we need to field is for, okay. tunnel IPv6 address. Let's do this. Let's get this straight, folks. Let's get all these straight here. IPv4 sort tunnels, IPv4 source address, IPv4 destination address. Yeah, let's write it up that way, right? IPv6 source. All right, what's happening? Excel, what are you doing? Stop jumping over there like that, please. IPv6 source and IPv6 destination. Okay, IPv source address is the interface address. Let's look here. Packet captures, IPv6, tunneling 6 and 4. Now I'm just going to go ahead and copy this into the repo. Yeah, 6 and 4, 624, and GRE. So let's go back to 6 and 4. And the destination address. Let's go to our 6 and 4 tunnel. Six, 2, 4, 6 and 4. Make that a little bigger. Description manual, tunnel, no IP address, IPv6 enable, IPv6 rip, tunnel source, and the tunnel destination, right. Okay. Manual add to tunnel interface. Okay, yes, that is correct. Now IPv6 source address. That in this case, for example, is the global address. However, here tunnel 66 source tracking sublog associated with GI00. Yeah, 2001 B16. Okay, so in this case, the IPv6 source address derived from source interface address, or assigned tunnel address. I believe that is correct. And the IPv6 destination address yeah, I don't think we need a field here. I mean, this is always going to be the remote. This is going to be triggered by either a dynamic routing protocol or a static route, right? Yeah, I don't think we need to note anything here. Let's see. IPv6 addressing formats. Yeah, tunnel IPv6 address. Global assignment. It's global format and assignment. Global address format, manual assignment. Yeah, I think just format will work here. Okay, run this one. Tunnel link local address format, IB4 tunnel address assignment. Yeah, I think we could take that out. Why does it jump like that? I don't get it. MTU considerations and bytes. Should we say this is the minimum NTU, MTU? I will leave it like that for now, not overcomplicate it. Use case IPv6 islands, advantages dynamic tunneling, disadvantages does not support IGPs, no global reachability for, oh, and the global reachability is a problem. We know that, okay. All right, I think that's good for auto 6-4 tunnels. You know what we should do right now is look at Necker cubes. Let's look at the flashcards. Just do a little review, see if there's any other gotchas. I need to do this a lot more, folks. 6-4. Preview. All right, see how we do here. Cisco iOS supports configuring blank automatic 6-4 tunnels on a router. I have no idea. Oh, really? Only one? Good to know. I did not know that. How many cards are there, by the way? 9 cards. Okay. How does automatic 6-to-4 IPv6 addressing work? The destination address. Well, the destination IPv4 address is derived from a special prefix and an embedded IPv4 address. IPv6 subnet 2002 is reserved. The full IP is derived from the border router's external facing IPv4 address encoded as hexadecimal. The tunnel interface would have an address such as, while the internal facing interfaces could have addresses such as, oh, okay, hold on a second now. The internal facing interfaces could have addresses such as, okay, I'm not sure I'm following on the external and internal. So the external interface here for IPv6 like there's no NAT going on here. There's no inside outside. Yeah, the tunnel interface has this, while the internal facing interfaces could have, now these can have other addresses too. I don't see what the distinction is here. Alright, I'm not gonna go down the rabbit hole here. For Cisco recommendations, when should 6-to-4 tunneling be used and when should isotap tunneling be used? So 6-to-4 should be used to connect IPv6 islands over an IPv4 backbone. And isotap should be used on to connect IPv6 hosts on the same LAN, basically, or to access the internet. 6.4 should be used to connect isolated IPv6 islands with point-to-multipoint links over IPv4. Isotap should be used to connect within a single IPv6 domain with point-to-multipoint. Yeah, you can also connect to the internet, I believe. Let me see if that's how I have that worded in my sheet here. Use cases. IPv6 islands. I can add the links using point-to-multipoint links. And isotap. We'll just say multiple domains. Dual stack hosts. Dual stack single IPv6 domain over an IPv4 network. I like that. All right. The advantages are dynamic tunneling. Yeah, it's dynamic. Okay, good stuff. What else? Oh, what are the two main differences between 6RD and 6 to 4? The two main differences. Well, one is that 6RD is ipv6 rapid deployment, enables access to the global internet. That's one. The other main difference is that 6RD is not limited to, it can use any global address prefix. Yeah, 6RD does not require all 32 bits. It's a matter of interpretation. 6RD does not require all 32 bits of the IPv4 destination to be carried in the IPv6 payload header. Okay, don't worry about that too much right now. What is 6RD? Yeah, similar 6.4, more flexible. What is the IPv6 format of an automatic 6 to 4 tunnel border router? It is 2002:/16. What is 2002 IPv4 format? 32 bits of the IPv4 derived. Yeah. 2002 border router IPv4 address. What 3 steps are involved with configuring automatic 6.4 tunneling on a border router? So, your computer just died. That's no fun. All right, I have 2 drinks here. I have cold coffee and a new cold drink I got out of the fridge, some dyed green tea citrus. So anyway, we're gonna switch back and forth between those two. Anyway, what 3 steps are involved configuring automatic 6 to 4 on a border router? So you have to, 1, tunnel mode IPv6 IP 6 to 4. You create the tunnel interface. Configure the mode, and then you essentially have to create a route. Tunnel, static route, internal interfaces. Yeah. IPv6 address. Azira Nitro. I'm not familiar with that. Here's some nice off. There's some nice iced coffee here in the UK infused with nitrogen. Oh, I've seen that here also. Not that brand. How does that taste? That's Nestle. Okay. So it's probably here as well. Yeah, I think I've seen that. It is amazing. Okay, I'm gonna add that to my list right here. I'm gonna make a note of that. That's your I think I've seen it recently, like took a couple flights recently out of Orlando and saw it at the airport. Oh, yeah, I love some coffee, man. I love some coffee. You gotta have it for CCIE too, in most cases. Okay, so interface tunnel. Now, this is interesting because show run interface T76. Yeah, okay, you have to have the IP address, tunnel source, tunnel mode, and then IP, and then a route, and then you have an internal interface, right? This is going to be your source and destination through the tunnel, right? It's interesting that when you think about the addresses on the tunnel, those are always going to be for the control plane only, right? you wouldn't really direct data plane traffic to these IP addresses. Not to go through the tunnel anyway. Right? Okay, going back to the cards here. It is a little pricey when you buy it individually. Gotcha. Probably need to buy it in bulk, right? To get the best deal. What's the primary difference between 6N4 and 624? The primary difference. One is static, the other is dynamic. .6N4 relies on static tunnel and works by encapsulating the ipv6 payload directly after the ipv4 header. 624 automatically generates the tunnel endpoints based on the ipv6 and uses 6N4 for transport. Hold on a second now. Works by encapsulating the ipv6 payload directly after the ipv4 header. Is that true? Okay, I see payload here after the ipv6 header. In other words, ipv4 encapsulates the ipv6 header and the ipv6 payload. .624 automatically generates the tunnel endpoints and uses 6N4 for transport. What? I don't know why I have so many troubles with these some of these cards. The wording is just... Yeah, how is that any different? You got IPv4, IPv6 is encapsulated inside of IPv4. There's nothing different than IPv4 encapsulating the IPv6 payload here. I don't get that. The major difference is the addressing, how you come up with the address scheme, and you can't really tell a difference in Wireshark. The only way you know the difference between one or the other is that one has to use a specific IP prefix. Other than that, there's no way to tell a difference on the wire. Yeah, it could have just said static. One uses static tunnel configuration. The other automatically generates the tunnel endpoints. Simple as that. Don't agree with that card. All right, so cool. Let's move on to the next. Spent a little time with that one. That's okay. Now this is interesting. Okay, 6 to 4. By the way, it's interesting that Network Lessons has another name for this. It calls it 6RE. IPv6 routing encapsulation. I just noticed that. Okay. All right, so going back to... No. Give me the window that I want, please. All right, windows are getting a little out of hand again. I can close that. And I think we're ready to select a new playlist here. All right, I did close the window. All right, so I wonder if it's going to go over in this course Teredo tunneling, Teredo. Oh, 6RD, good. Yes, I've been looking forward to this. Yeah, as it says here, due to the major limitations of IPv6 or 6 to 4 tunneling, that is why ISPs never implemented it, really. .6RD builds upon 6.4 tunneling. It gets rid of its biggest weakness, the use of 2002-16 prefix. Okay, so let's fill this out here. Network Lessons is skipping this, so let's make this, let's put like a little marker here or something. This is like design, more design related. And the other portions are spreadsheeting is hard. Okay, where is the man? This is a little different from what I'm used to in Excel. Look at that draw, interesting. There used to be a button that allowed you to change. Okay, here we go. Yeah, that's what I'm looking for. Oh my gosh. Used to allow you to, all right, anyway. Jeez. Jeez. Line style. That's so not what I want to do here. All right, we just changed the, I know what to do. All right, so use case for, and let's, let's freeze right here. Okay. Spreadsheet's getting big. So 6RD, IPv6 islands, IPv6, dynamic tunneling, global reachability. Yeah. Okay, good. Okay, so ISP has an internal IPv4 network. Each customer has a CE, or residential gateway, with an IPv4 address on the WAN side. On the LAN, we can have IPv4 and IPv6 hosts. When an IPv6 host transmits a packet, the CE router encapsulates IPv6 packet and IPv4 header. Depending on destination, is transferred to another CE router or the BR, the border relay router of the ISP. BR has IPv4 address, right, and provides connectivity. Okay, I know a lot of this already, but let's think about the IPv6 address format and write this out. Okay, so IPv6 prefix and prefix length that the ISP wants to use for 6RD. Embedded IPv4 address in the IPv6 prefix and a 6RD border relay IPv4 address. ISP decides on all this. Yeah, we can get our IPv4 address from a DHCP. The IPv6 prefix interesting, okay. There's 3 ways to get this IPv6 prefix. DHCP option 212, okay. Is there a lab in here for this? I hope so. There is. Okay, okay, all right. All right, let's build us a lab here. Okay, we have BR1, CE1, and CE2. I think we'll get right into the lab because I've already kind of covered this and I don't want to read that on stream, so can't really show that on stream. That's, ooh, what did I just do? Something moved. Where did you come from? I need to lock this lab when I'm done. We have a cloud that's lost. I wonder if that was duplicates. Well, I'll be all right. Do I have a screenshot? Yeah, not gonna worry about it too much. Actually, may leave it here for now. All right, so let's talk about where we're going to hook up the 6RD. I'm thinking I may do it that has 2 interfaces in use. This could sort of act as ISP. It's already acting as sort of a service provider router. So is this, though. We may just add a router. Yeah, do something like this. Yep, let's do that. You know what I need to do? I need to save these configs. There's some unknowns with this environment because it's getting so big. I don't know how it's going to act, and I don't want to lose any work. So that was R16. Which we didn't really make any changes there, I don't think. And this is getting hard to see this router name. There we go. Oh, that was him, R16. Okay, he didn't change. These changed, so let's do a save here. And then export these configs. And export this config here. And then it's interesting how this is sort of blocking out my menu here. Because of the size, probably. All right, selected coffee in this instance. Okay, so let's go over here to zoom out a little bit. I know what I need to do. I'm gonna put this way down here because I'm having trouble a little bit with like scrolling at the edges. So this will give me the ability to scroll. Yeah, should have done that a long time ago. All right, yeah, let's add a router. Router 41. One node R41. All right, just setting up my eVinstance now. Is that an AWS? We're going to stop this router here. And now we can zoom in a little bit more and scroll. And we're going to stop this router. And we're going to connect these two. Actually, this needs to be a shared segment, I think. So we're going to put in a... I'm thinking about putting a switch in here. Yeah, let's do that. Why not? What did I call the other one? So far I only have, I have this switch here, switch 1. Yeah, let's do it. Look for a minute. Hey, that's fine. Yeah, I need to just confirm my boss around the AWS stuff. We recently had a few instances where people spent thousands of pounds on accident. Oh, yeah. That's not good. Wasted money, man. AWS loves that, I'm sure. Okay, switch to. Yeah, things are getting kind of tight. I really do need to pull stuff out a little more. Managed to get some back, I think, but yeah. Interesting, really. You're able to actually get some back? That's a little surprised by that, I guess. Always do the vertical line. And let's hook these bad boys up. J00, let's go J01. Actually, let's do 2, J02. Some of the spending was because somebody had pushed private keys to the cloud. Oh my gosh. Oh. You know, people try to automate, which is great. Oh man, on GitLab? Oh my gosh. That's... You know, the weird thing is, like, GitLab allows for private repos too. Oh yeah. Jeez, that is wild. That is wild. Yeah, GitLab allows for private repos. That's one reason I use GitLab for some of my personal projects, because I can have private repos. Like I have a repo actually to sync up these lab configurations. Spun up a bunch of X4 large instances. I think that's what they're called. Sounds like a resume generating event. Yes, it does. Man, public keys? Well, public keys, were they... I guess it depends on what kind of keys they were. Oh, private keys, yeah, private keys. Yeah, ooh, not good. Okay, we need a new type of cloud. Yeah, whoops. Oops, there it is. Yeah, let's get a new cloud going here. Now I need a new cloud. That is the one thing, when you get 41 routers and a few switches in here, things run well, surprisingly well. It's the redrawing of this interface that I notice, like, does slow down a little bit, which is not a big deal. You're not editing, it's not like you're using Visio here. Yes, we're gonna call this a L1, L2. Where'd that go? Oh, is that from this? Yeah, see, it's... Okay, this is going to be our 6RD domain here. And we're going to make 6RD, we're going to give it a different sort of background color here. Doesn't really matter. The only requirement's that it be somewhat easy on the eyes, not too harsh. Yeah, we don't really have any brown. There we go. And duplicate. 6RD. I've always felt like that labbing this would really help me cinch some of this for me. Just some of the like IPv4 formatting here. Conceptually, I think I have it. It's just anyway, let's sign. Well, so we need a global prefix. So we need a global prefix to use externally and internally. Two different prefixes. So we're the ISP and we got to come up with some. So let's just copy this because we're using purple for IPv6. And we'll just make something up here. The last one I used was 2003 FFFE. So let's go with something else wild and crazy. 2003 FFF FD. Of course, this is gonna have to be derived, right? So I may wait on that a minute. Okay. We'll just put a placeholder here. And I want to be able to do that and then lock the lab because I'm gonna need to start doing that so I don't knock any, or nothing gets knocked out of place even accidentally here. Yeah, so there'll be loopbacks on each of these routers. And then internally is an IPv4 network, right? Yeah, let's position these. Okay, we need to do a little bit of work here. This goes here. I want this on top of that. And these guys are all scrunched up. Let's help him out a little bit. Shoot. Okay, let's move this. Move these down. Hey, we got a new follow. Who dat? Who dat? All right, XDD, thank you for that follow. Appreciate it. I try to stream, just in case anybody's curious, my schedule. Yeah, that's still correct, pretty much. I'm on a studycation right now. Don't have that running yet. I do not. Eventually I will, but yeah, not yet. Haven't. I started this lab as part of my network lessons review of a lot of protocols prior to attempting the written exam again. And I'm trying to think of where I started, like what was the... Yeah, to be honest, I can't remember. ISIS is where I started. And then I skipped a lot of the IPv4 routing protocols in network lessons course because I feel stronger on those than I do a lot of other stuff compared to like IPv6 and tunneling, DMVPN, all the VPN technologies. So the last time I took the exam, VPN technologies was my weakest area, I believe. So yeah, I'm trying to beef up on that. Okay, this is okay, I think. We might move him over just a little bit. Yeah, let's do that. And this could be wider. Don't want to spend a ton of time on cosmetics here, just usability. Took me 4 tries to pass that Joker, man. Oh, congrats, ActDD. Congrats on that. Yeah, I got a rude awakening the first time. That was at Cisco Live in August, I believe. My first Cisco Live, and then I got mad and tried to, you know, cowboy it again, take it again like 6 weeks later, and did worse. So I'm like, okay, hold your horses, take pride out of it. And let's get a good pace here. Let's reassess. And Siri thinks I'm talking to her. Oh, got some messages here. Yeah, congrats, XDD. Yeah, I've told myself if I fail it again, that's okay, because it's just so broad, man. It's just... And until recently, there was no official study guide for the evolving technologies. I thought I did okay the first attempt, and I feel like I did, you know, decent. Keep it up, man. I found watching. Yes, I've started to do that too, in the weaker areas. It seems like a lot of the presenters at Cisco Live are also on the board. And that information does, as a matter of fact, I have seen slides at last Cisco Live and on-demand sessions. I saw slides that were the same as questions in the exam. Yes. So I found that, yeah, good, very good tips, very good tips. That's the only problem with this in Eve is once you get some really large topologies, the community edition is limited in terms of the editing capabilities. All right, we got some mismatched stuff going on here. Two, four, okay. That's good, that's good, that's good. I'm not gonna mess with that anymore. I don't know why there are two. Let's just check and see. $115 and $112. Okay, that's right. Why is this saying 26? Oh, with Eve, I find it easier to make the diagram Visio draw. Oh, really? Oh, that's a good idea, XDD. Whoa, mind blown. I love it. Thank you for that. I am going to definitely... Can you export as well? Like, I'm actually syncing. Like, I have a Pro instance in my VMware Fusion locally. No, I mean, like, if you originated it, the topology natively in Eve, are you able to export it and open it in Draw IO? Like, does this end up being a PNG file? Let's see, SH. There's these UNL files. Actually, I've not backed this one up in a while. I need to. There's a schema. SQL. Okay. I'm definitely going to look into that. That is awesome because, yeah, this is getting to be kind of tough. Want to hear a joke about UDP? I've never done that. When my EU is usually just a mess. I just use a diagram I make. Yeah, that makes sense. Especially for big ones, right? Because the editing tools... the Pro Edition has... a few more things, like I noticed creating lines and stuff, and you can do what do they call them? Beziers, or you know, but yeah. Man, I'm gonna do that for sure. You know, this thing has just kind of grown on me. I never thought, I didn't really set out to make a lab this big, but I'm you know, basically conducting an experiment here to see how well this works in Azure and how much it costs, you know. Okay, so he's good. We're still a little uncertainty about this prefix. I don't know where that goes. I know that this goes here. You know, that's okay, because we can always... If we don't know what... Oh, I bet it went here. Will that work in this topology? This is 6 to 4, or 6RD. It will, because these are supposed to be connected anyway. All right. Yeah, want to hear a joke about UDP? Let's go. I guess I never know if you got it. That's right. Good one, man. I actually, in our channel, we have in our Discord server, we have a we have something on humor. I forget what it's called, but fun with networking, yeah. We've got some RFCs in there. Like, we have an RFC Hall of Fame for some of the funniest RFCs out there. Yeah, hilarious stuff. All right, don't have a look back for that. That's okay. I have a new IPv6 placeholder for the loopback. And I have a placeholder here for the global prefix. Yeah, April 1st RFCs are amazing. We also need, okay, this is going to be an IPv4 network. So we'll just duplicate one of these. And we're just going to say this network is 10.0 250.25 119 dot let's do a CIDR that we don't use very often, that I'm trying to learn better. Let's use 19. So this would be 119. Let's see, 19, 16, 17, 18, 19. So it's 128, 192, 224. So our subnet sizes will be 32. So 32, 64, 96, 128 plus 32 is 160, 192 plus 32. Yeah, so we'll do 96. Why the heck not? Yeah, that's a great one. IP over AV on carriers with quality of service. I used to have a Hall of Fame out here. Internetworking has been retired, by the way. So ping and traceroute are also end of life and end of sale. I have screenshots to prove it. Yeah, I think it's still out of my Google Drive share that I haven't moved over to GitHub yet. Yeah, RFC Hall of Fame. Scenic routing for IPv6. Hypertext Coffee Pot Control Protocol. Infinite Monkey Protocol Suite. Morality in the routing area. Let me put these out on plain text. Well, we'll do RTF. Yeah, I need to retire this from... I'm trying to retire my Google Drive share and get everything in. Yeah. Is RTF open source format? I don't remember. Notes. Yeah, we'll just put it in notes. Let's update Git. New pcaps and fun doc. All right, they're up there. And I can retire this. Okay. So we got this, we got this, we got this. Making sure this is at least somewhat manageable here. ISIS. Yep, okay. Let's scrunch this up just a little bit. Put this here. Fine. Okay. Anything else? ipv6rd. All right, start these bad boys up. And I think we should probably lock the lab. Oh crap. Whoops. That's why. All right, so hopefully we get to this. Hopefully at least we can either get this lab built. I'll probably be breaking for dinner at about 6 p.m. my time, so in less than an hour. But I hope to get this at least built before that break. Yeah, I have to connect to the public IP just because that's the only way that the wrapper will work, the Wireshark wrapper. At least the only way I've figured out to make it work. Yeah, let's lock the lab. Getting bigger, man. Yeah, that works, I think. Okay, let's zoom in. And move this over here. All right, everybody's looks like they're getting started up. And let's open our, all right, this is gonna be the border router. Got our switch. And then we have, this is gonna be like CE1 and CE2. That's the issue with all these labels. Oh, it's locked. Yeah. What is it trying to... Oh, it's that? Hold on now. Okay, CE2. Why is that acting like it's... Oh yeah, it is just booting up right now. All right, the switch. Let's see. Host name is SW2. Interface range Jazz0033, no shut. And then I do want to sort of label the border router. Just because I keep forgetting to call it a border router. Also, when I think about BR, I think about Halo battle rifle. All right, BR, and then, all right. Get that, okay. Let's configure, we need a VLAN configured here. They're all gonna be on the same shared segment. now we can separate these. Move this here. Move this over here. And I think we're ready for a new playlist too, folks. I don't have, I think I only have one more, but that's legitimate for YouTube. Okay, let's see. Interface range GI0 1 through 3. Switch port access VLAN. 4094. Switch port mode access. And yeah. We didn't really need a big switch for this, but I just wanted to add it. I want to keep stressing the lab. All right, router 13 show IP interface brief. Okay, we need to assign HCI00 IP address 10.250.96. Let's see, this is our, so we're gonna do 97. What's the upper end of the range? 96 plus 32 is 108. So let's do like 107 will be the router, and we'll do, yeah, 97 is fine. And let's do .0 just to be ridiculous. 205 dot what do we say, a slash 19, so 220 224.0. We're sick and twisted that way. All right, 14 is going to be, oh, please answer yes or no. This is 41, sorry, this is the new BR border router. He should be here. Okay, this is CE2. Base GI00, IP address 10 dot 250 dot 98.0. Okay. And now show IP interface brief. We'll just make sure we have basic connectivity ping 10.250 dot 10.250.97.0. Oh, it's shut down. Thought I had enabled these. Interface range, GI0, 0 to 3, no shut. Yeah. All right, success. And this one's going to be host name is R41. And interface range GI0, 0 through 3, no shut. There are certain commands that I systematically mistype. I do that a lot. Con space FT. My brain gets ahead of me on that one a lot. I need to fix that. There's another one I do all the time. Anyway, interface Jazz 00. Excuse me. And IP address 10.250. And this one will be 107. Show IP. Yes, that's Pocket Pilot. How's it going? That's the other one I do. Yes, that is the other one I do a lot. You know, we could have made these a little crazier. 107 to 254, right? Is that the last usable in that range? I think it is. We'll find out. 255.224.0. Ping 10.250.107.0. Oh no, .97.0. Yay, yay. All right. Okay, so those are done. Now let's look at. Okay, this ISP is going to use an RD6 prefix. I'm doing as well as someone with the first snowfall in Michigan can. Oh man, you know, I always love. Everybody loves the first snowfall, right? Everybody loves the first snowfall. It's the subsequent snowfalls and the subsequent cleanup that is always a bummer. I do miss the snow. I haven't moved to Florida. I haven't seen snow in a minute, and I do miss that. But I don't miss the cold. We have a small ISP network 1BR. Okay, this ISP uses. Okay, so I can use really any global prefix, which I have assigned here. Let's say we have a global prefix of, why not a 32? Although I wonder if that's duplicate up here. Will that overlap? 2003 FFE::6. Now those are 128s, but nah, it should be fine. So to the FFD. Okay, what I'm not sure about is. Okay, so this is going to be for tunneling. This is our tunneling prefix, but we need another loopback that represents the internet. What's a good one? We could use, well, I don't want to use this one. We'll just pick one. Won't make a big deal out of this. Duplicate. So we're going to give him another loopback. I think this is a Google one too. A 2001 4860 4860 8888 /128. Is that Google? Does Whois work the way it does in ipv4? It does, yeah. Okay, yeah, we're gonna pretend that we are Google here. This is the internet. And this is our global prefix that is assigned to our organization. And let's line these up. Ah, that's alright, don't worry about that. Alright, let's configure that interface on R41. Interface L416, ipv6 address 2001, 4860, 4860, 888. Okay, done. Each C router is a loopback. It represents a LAN of the customer. Okay. All right, that's fine. So let's configure a loopback here. So if we have this /32, that means we're going to want to divide this up. And let's give, you get a 64 and you get a 64. Well, I already have labels for that. I didn't really need to recreate this, but yeah, that's what these are. So this is going to be let's give him FFFD colon FFFF colon 13. Boy, that's getting long, isn't it? Let's shorten that up. It doesn't have to be that long. Colon 0, colon 13, colon 1. That'll work. All right, this one will be 2003 FFFD colon 0 colon 19 colon 1 /64. Okay. All right, and let's assign those out. Router 13. Trace L136. ipv6 address. I think that's how we're doing it. No, that's not how it's being done. Okay, let's see. HC router is a loopback interface, represents the LAN of the customer. Cisco does not support DHCP option 212. So manually configure the IPv4 addresses. And manually configure the RD6 prefix length, and BR IPv4 address. Okay. So the way that is done is no interface L136. ipv6 unicast routing. Both the CE routers, we'll use this. And create a general prefix. Okay, so ipv6 general prefix ISP 6RD. Oh, RD6 prefix 6RD. What are the options here? Yeah, 6RD. Tunnel 136. All right, it is down. In order to bring it up, we have to interface T136, ipv6 enable. Went out off to bed. Cheers for the content. It's been fun. Hey, thanks for hanging out, Kieran, John, M, and thanks for the sub. And hey, we'll see you back here probably tomorrow if you have time. And have a good night. Enjoyed having you here. Good discussions. All right, tunnel source. Good bits, man. Tunnel source GI00. Tunnel mode ipv6 IP 6RD. And then tunnel 6RD IPv4 prefix length 24. Tunnel 6RD IPv4 prefix length. Our prefix length is 19 actually. And then the tunnel 6RD prefix is 2003 colon FFFD :/32. Interesting. And then the tunnel went up. Okay. Okay, and if we want to reach hosts on the internet, we have to specify tunnel 6RD border router is 10.250.107.254. Ah, okay, I see. So what we have to do now is we have to create a loopback to simulate the IPv4 network. Wow, there's a few layers in here, man. This is interesting. All right, so we're gonna create interface L1364, I'm going to call it. IPv6 address, ISP RD6 underscore prefix, colon, and then we have to simulate an IP address here. So we're just going to use 10. It almost seems like it's too many. All right, I'm gonna go with it. I'm not sure I understand that command yet. To simulate a prefix on a LAN, I use a loopback interface. I need to think of a prefix, so I'll use 10 as my prefix number. We can refer to the general prefix we created easily. Okay, so there's a prefix, an IPv4 prefix, and a host, I guess. And then we need a static route for the prefix that points to the tunnel interface. So I believe this is IPv6 route 2003:FFFD :/32 is going to go to the tunnel 136. And then a default route, IPv6 route :/0 will go to the so this has to have an inside interface, essentially. I think. Yeah, there's our IPv4 prefix, there's our IPv6 prefix. And this is our inside and then this is our external. I think that's how that works. So this will be route, our default route is going to go here. Interesting. Okay. All right, let's go to our other CU router. It's going to be pretty much set up the same. IPv6 unicast routing, IPv6 general prefix, ISP_D6 prefix, XRD tunnel 196. Interface T196, IPv6 enable, tunnel source is GI00, tunnel mode, IPv6 IP 6RD, tunnel 6RD IPv4, prefix length is 19. Tunnel 6RD prefix is 2003:FFFD :/32. And the tunnel comes up. Tunnel 6RD BR is 10.250.107.254. Now we do new interface, loopback 1964. IPv6 address is ISP_RDP RD6_ prefix ::, same. Okay. Interesting. All right. Then we have IPv6 route to the prefix 2003:FFFD :/32 will be to our tunnel 196. What didn't I like? Oh, :/32 T196. Get ipv6 route, :/0 to 2003, FFD, FD, :0:41. That's it. Okay, CE routers are configured. Now let's go to the border router. I'm not going to remember any of this, but that's okay. It's an exercise, and we want to get some PCAPs. We want to be able to do some debugs or show commands just to see what all this looks like when the tunneling is all up and routing is working. Okay, ipv6 unicast routing. Interface T416. ipv6 enable. Tunnel source is GI00. Tunnel mode ipv6 IP 6RD. Tunnel 6RD ipv4 prefix length is also 19. Tunnel 6RD prefix 2003 :FFFD :/32, and ipv6 route 2003 :FFFD :/32 is to tunnel 416. Okay. Only need a static route for that prefix that points to the tunnel. All right. Whew. Wow, a lot of stuff. All right. First of all, let's close this window. And let's save this config, albeit very, very basic. And let's see if this stuff actually works. Show tunnel 6RD. Tunnel source 10.250.97.0. 6RD is operational. B4 prefix length. B4 suffix length, not configured. Border relay address, general prefix. Okay. That says 2003 FFFD :800. I don't remember configuring 800. Yeah, what does it say on the other ones? $1,000. Yeah, that is not correct. I need to figure out how. ipv6 general prefix. We'll create a general that we can refer to by name that is based on a tunnel interface that we'll create next. So I'm trying to figure out how it came up with like 800. What is it on this one? Show tunnel 6RD. General prefix 2003 FFFD 5FF0. So how does it come up with that? Is that just show run interface T416? Tunnel 6RD prefix. Oh, did I not put that on here? Show, run, include, general. It's not on here. I don't think that the order router needed it, maybe? Let's see. Yeah, it doesn't have a general prefix defined. Oh, is that base? So that's derived just like the other general prefixes. So that's what I need to use. On my routing table. Okay, so that's fine, that's fine. The route is based on or is it general prefix? This is what my default route needs to be on the other, this right here. But where does this general prefix come from? Show ipv6 general. Yeah, this is acquired. $800-0800. Okay, folks, that's my cue to take a break. I'm going to eat some dinner and I'm going to come back. We're going to keep labbing. So thanks for tuning in, folks. Everybody that's here, this has been great. Man, I've always wanted to do 6RD. I say that it's confusing, but we're going to kind of unpack it. So we've configured it thanks to the help of networklessons.com. That has shown us really a configuration, and this lab is based on their lab. But now we need to sort of unpack it and figure out exactly what's happening and make sure that it's actually working, right? So we're probably gonna have to build some more traffic over here, like outside, beyond the ISP router, just for fun. And just to make sure we grasp the concepts and principles. So anyway, thanks for stopping in, folks. Appreciate you hanging out, and I will, just feel free, if you haven't yet, you can subscribe here on Twitch or click that follow button. If you have a free Amazon Prime sub you haven't used yet, would love for us to use it here, the support channel, and then you can turn on the notifications as well to see when I'm back on. I'm going to estimate like an hour, and we'll be back on to lab through the evening. So sending good bits to everybody, despite whatever you're doing this weekend, and appreciate the chats and the support, and we'll see you back here shortly, here on the LAN Tamer stream. Good evening, we're back for session 3 of ipv6 tunneling technologies. So far today I have run, well actually let's do just a quick bit of review here on where we're at. I am. Go back to the top of this, see the outline here. Yeah, I'm working on right now. I just completed the configuration of the ipv6 6RD lab here in networklessons.com. Earlier did 6N4 and 624. Oh man, I still got isotap and ipv6 over. Okay, man. I was hoping to get done with this unit today. It may not happen. It may or may not. Let's see. I've forgotten about those others. So yeah, got those done, and we've done packet captures. I'm working on a chart here. Like updating this chart. I know it's zoomed really large. Man, getting used to this new version of Excel. Yeah, so filled out 6 to 4 most part. Now I'm working on 6RD. ipv6 rapid deployment, static. Not really. Let's take a look at a package capture. So that's where we're at. We're continuing to work on that. I've got my topology right here, 6RD. And these are the... Let's zoom out a little bit. Get this in focus. Plan to lab for another hour or so before breaking off. And we'll be labbing tomorrow as well, folks. So I'm about to wrap up day 4 of a 6-day studycation, I call it. So yeah, I've been studying solid, getting ready for my CCIE written exam, New Year's Eve, December 31st. So 52 days, I think. So that's where we're at. And let's see, I've got here. So we've got this external loopback I've created. This is to emulate the ipv6 internet. And we have our 2 routers that are, you know, CE router, CE1 and CE2 basically. And then we got our border router here. And these are the loopbacks that are being used on each CE router. And this is the loopback on the border router, the internal. Because we're sharing a prefix here, right? The service provider owns this prefix. And it's kind of doling out and doing tunneling over an IPv4 backbone. So this is an IPv4 backbone here. 10.2.10.96. But yeah, the prefix that is being shared is this one, 6RD 2003:FFFD:/32. So we've got it set up based on the lab requirements, and I was just checking on it now. Let's look at our tunnel interfaces. All right, so this says it's up, tunnel. The tunnel source, of course, we're tunneling this way, right? And we have... That seems a little loud in my ears. I don't know to you folks. We've got tunnel source track and subblock Jazz 00. And tunnel port protocol transport ipv6 6RD. And if we look at the tunnel interface, show run interface T416, tunnel mode. Notice we don't have a destination, right? But we're telling the tunnel, okay, this is sort of derived, right? This is going to be your IPv4 prefix that we're going to use. And this is the prefix 10.250.96.0/19. And then we have our 6RD prefix, 2003:FFD:/32. This is our tunnel mode, and that's really it that's here. We have IPv6 enable. We also have a route. Disconnected route 2001 46 40 60 888. So the route Oh, we're receiving this route. Interesting. So we have a static route, FFD:32. In other words, any traffic that you need to... This is interesting. Not quite clear on what that is. Yeah, I definitely need to do some reading on this. I've skipped a lot of the reading that's in this lesson. Kind of jumped into the configuration part because I was on stream. But I just want to check the work here. Show tunnel 6RD. Let's do that. Show tunnel 6RD. Edit tunnel source. Looks good. It says operational. V6 prefix, V4 prefix, and suffix. Order relay address is not here. Oh, that should be on the CE router. We should see that. Show tunnel 6RD. Yeah. Yeah, that is the border relay address IPv4 for the BR border router. The general prefix 2003 FFD:. Now this is what I don't get, is this general prefix portion. So I'm not sure how it got this. Show IPv6 general. Loopback 1364. Did it derive it from the show run interface L1364? Yeah, I'm not sure what this is used for. So this is 10.0.0:1. This is the part I'm unclear on. This is the part that has me confused. Because what we did is we created, I created I don't know if that's a section you can run against or not. Yeah. So I created a static route here. I guess that doesn't matter. Okay, so it's going to route anything for that towards the tunnel. Oh, this is why it matters. Because I'm supposed to route to this, but if I look at this, show IPv6 interface. I want brief. This is using a different address here. Well, that's a FE80, but show. Do I need two loopbacks on the border router? Yeah, show tunnel 6RD. So this is actually what I need to have my default route go to. 5FFF0, that must be derived. All right, let's just do that. No IPv6 route, :/0 to 3 FFD:041. Yeah, I think I derived that incorrectly, because that's not... That is a general prefix address. Let me see if it'll let me copy that. IPv6 route. And you won't let me copy to a different window. ipv6. Why doesn't it like that? Okay, FFFD. The general prefix says FFD colon 5FF0. Show general prefix. Oh, I gotcha. Okay, so I'm not supposed to put the... There we go. I do show run ipv6 route. Let's open our Diet Coke over here, get some caffeine going here, folks. This is picking my brain here a little bit, which is okay. Okay, let's see, no ipv6 route default. It should be ipv6 route 1003 ffd colon 5ff0. Okay, now we should be up to speed with with everything that is configured in the Network Lessons lab, more or less. Okay, let's just make sure all the tunnels are operational. Show tunnel 6RD is. And it is good. On each router we see IPv6 RD6 prefix, the IP4 network address and prefix length, and the prefix that the router can use. This prefix has the IPv4 address embedded. Does it now? Well, let's just see. That's weird. Okay, I did a copy. All right, let's just do VS Code. All right, so we're using a, make sure the chat's alive there. We're using, all right, so 8800. It says this is embedded. So F is, if we go backwards here, F is 15, 15, 15. Let's see, A, B, C, D, 10, B, C, 13. And then we have 88, so 8. 88 is 8 times 16. I want to try to figure this out on my own here. 8 times 16 plus 8. Yeah, so 136. Oh, okay, right. So 15 times 16 plus 15, right? So 205 dot, take these two, F and D. So D is 240 plus 13, is that right? 15 times 16. .255.253.136 dot 0. Are some of these bits turned around? All right, I'm gonna just move past that for now. All right, so theoretically, it should be generating IP addresses. Show ipv6 interface. Oh, okay. Show ipv6 interface brief. Gotcha. So it's generating this interface based on the prefix show run interface L1364. Okay. S3 FFD. Huh, interesting. All right, so in this case, if we look at this address, .2003 FFFD is the prefix. It is the embedded okay 800 800 is the embedded IPv4 address. And then, oh, okay. No wonder I didn't understand. I remember reading about this. It has to manipulate these bits to use multiple, to allow multiple. 10 is the subnet. Interface ID is 1. Okay. So when we did this, this is the subnet is 10. The interface ID is 1. Yeah, because we have 2003 FFFD. Man, I was trying to do something way different. All right. And there's just 1 8. I even put an extra. All right. So I have 2003 FFFD 800:10::1. Okay, 800 is the embedded IPv4 address. I don't get this part. 10 is a subnet, 1 is the interface ID. I get that. Show IP interface brief. Yeah, how is 800 the embedded IPv4 address? Embedded IPv4. The IPv4 address of the CE is embedded in the IPv6 prefix. Default allocation is 32 bits, and IP address is also 30. This means that an ISP could only assign a single 64 prefix to each customer. All of this is explained in here. So I'm just going to have to go over this off stream, you know. But let's do some more testing. Apparently this works. Hey, mentors. Hey, man, I just joined you and saw you was converting IP. This article really helped me with the maths. All right, awesome. Thank you, mentors. Trying to see if I've read this. I don't think I have read this one. Yeah, this is a very unique, you know, this is a 6RD format, which is a very unusual and complicated method. Like it takes parts from here, parts from here, parts from here, parts from here. But I'm going to definitely check out that article. Okay, so we need to look at our routes. Show IPv6 route static. And good, we have 2, that's what we need. 2, we have our default, and then yes, we have that. This should only have 1, yeah. All right, let's send some traffic. So we'll start with traffic within our domain. We want to ping from basically CE router 1 to CE router 2. So I want to ping over the tunnel from here to here. So I think what we want to do is, let's see, show. Also, just curious, this topology shared on your GitHub? It is not as of yet. I have to figure out a way to incorporate that. I did create a Git repo, but it's private for now because I wasn't sure what it copied. Like I wanted to make sure that no image files were copied. And now I figured out pretty much that it does not, because I didn't want to do that, of course. So all I think this is a copy of the UNL or UNet Lab folder, labs folder. I think they're just text files. So yeah, I will be sharing this out for sure. Ping, let's see. Oh, gotcha. I enjoy shows 6-shooter. Yeah. 6-shooter labs. Show IPv6 general prefix, yeah. So this is what I want to ping, the 800. Or the 1000. Okay, ping. So let me try that. Show IPv6. Actually, we can do show IPv6 interface brief. So we're going to try to ping this. Ping 2003 FFFD colon 1000 10.1 source our own 3 FFFD colon 800 colon 10 colon 1. Missing no. Protocol not running. All right, let's back up a minute. Let's go to compare configurations here and make sure we have everything we need. Show run include IPv6. Upstream, if you got a sec, I want to ask you and even show if you guys would be interested in doing a talk with one of the discords I'm involved with when you're free. I'm sure some details once you're free. Yeah, man. I would like to do that. Okay, unicast routing is running. IPv6 Ceph is running. We have our loopback. (1364), yeah. Show. We have our tunnel interface. Tunnel source. Tunnel mode, tunnel 6RD IPv4 prefix length, tunnel 6RD prefix, tunnel 6RD BR. Make sure I can ping 10 250 107 254, and I can. And then IPv6 routes. (2003) FFFD. Show IPv6 route : :/0 2003 : FFFD 5FF0 : yeah. Could this be an image issue, I wonder? And last we'll look at the border router. Show run section IPv6. Unicast routing, IPv6 Ceph. Show run interface L416 2001 4860 4860 888 : yeah, that's fine. Show run interface T0 or T416 IPv6 enable is running there. That's good. Tunnel source 0. Tunnel mode IPv6 IP6RD previous length has 3. Yep, it all looks good. IPv6 route 2003 : FFFD : // yeah, that looks good. All right, let's look now at our CE2. Pretty much should be identical. Uh, 6RD. Make sure my spelling's not off here. ISP underscore RD6 underscore prefix, yeah. Show run interface L196. Ah. Loopback 1964. Okay. IPv6 address, ISP underscore RD6 underscore prefix. Show run interface L136. I have two, no, yeah, that's right. I have one loop back here. Show run interface L1364. Interesting. So that looks right. And then show run interface T196. IPv6 enable. Tunnel source. Tunnel mode. 6RD IPv4 prefix 19. I wonder if that has to be 24. Shouldn't matter really. Tunnel 6RD prefix 2003 colon FFFD colon colon slash 32. Tunnel 6RD BR. Ping 10 to 50 107 to 54. Yep, no problem. And show run clear IPv6 route. Okay. Tunnel 196 IPv6 route 2003 FFD 5 FFF0. Okay. Let's try it again. Let's try going to the outside. This address here, this Google address. Well, let's at least see if that works. Ping 1001 4860 4860 8888. Source. Shoot. Source is this. Hey, that worked. Okay, that works. Yes, let's do that again, and let's get a packet capture. Capture GI00. Okay, let's do that again. Do it again, do it again. Ooh, do it again. All right, so here we go. Let's take a look at this encapsulation. Interesting. So the source, this is the IPv4, right? Normal 20 bytes. Protocol is IPv6. Source in the destination. Ping. Okay, so you can't really tell here. I'm trying to think if you would be able to tell what kind of encapsulation is doing this. You would know it's not automatic 6 to 4 because it's not using as destination 2002 or even as the source, right? But it is using a global, so that's probably how you would know. I mean, otherwise it could be a manual. I guess by sort of looking at the format of the source address. So that's interesting. I'm wondering if I'm just using the wrong destination over here. Let's play with that a minute on the other ping. So I'm going to save this. Let's mark this packet and this packet, and we will export. And this is going to be our IPv6 tunneling 6RD inside to global. Honestly, I don't know if we'll be able to really tell the difference. Okay, so I might have been using the wrong address here. Show. Okay, that's the correct source. Let me see if this one can. Ping. Uh, 2001, 4860, 4860, colon 8888. Source is, oh shoot. Oh, it's right up there. Ping, 2003, 1. Source is our tunnel, our loopback interface, 2003, colon FFD, colon 800, colon 10. That works. Now we should be able to ping our neighbor over here. 2001, no. 2003, colon FFD, colon 1000. Source. 3 FFFD 810. Okay, it does work. Nice. All right, let's capture that. I must have been typing something incorrectly. Knowing me, I was pretty sure that was a typo. All right, let's do another ping. Nice, there it is, ladies and gents. Mark, stop. Nice, okay, so let's look at this. As we can see here, the source, destination, encapsulation type, just like any other, and IPv6, source, destination. Nice. All right. Export specified packets. And this one we're going to call IPv6 tunneling 6RD inside to inside. So everything's working. So it is stateless. So let's kind of wrap up this one. We can say it is stateless, yes. It is protocol 41. Yeah, we have these embedded addresses. That's what makes it kind of interesting. Routers look at the IPv6 destination. When the destination matches the prefix, it's considered within domain traffic. Ah, right. Okay. That's the part I was getting confused a little bit before. When the IPv6 destination does not match the IPv6 prefix, it considers outside domain traffic. We see the IP address of the BR as a destination. That's a really good lesson. Yeah, that is some good stuff there. I need to go back over and read through that a little more. And I'll see if I finish. So if I go back, just to wrap things up here, folks, what we'll be doing is, one, I'm going to be updating this document here. Let's just save it. And this packet capture, I hope I saved that. I believe I did. Yeah, inside to inside. Let's write the changes here. Let's save this. And this will become a permanent part of the lab, basically. And once we do that, we'll export the configuration. Just for good measure, I may save the whole thing. Let's zoom out. Phew, getting big. All right. We have 43 devices running, basically. 43 devices using viral images running here. And it's running great. I don't even think we've broken 50% utilization. Let's see. Last hour, let's say last 12 hours. Yeah, we barely broke 40. So tomorrow you'll be lab once again. I know Show plans to lab early and has plans for the evening. I want to catch both of you guys' labs. Cool, yeah. Yeah, mentors, I'll probably stay up kind of late tonight, and then I'll probably watch Show in the morning as well. So, you know, I'll be pinging you there, and then I will probably start up a stream whenever he finishes up, or later on, because I have Monday off. Monday is my last day of Studycation 2019. So I'll probably stay up late Sunday labbing, and then just get up, you know, Monday and finish up. So yeah, that's great, man. Good to see you back in action. Hope all is well with the fam, and with yourself, sir. Not just the family, but, you know, hope mentors taking care of mentors too. Sounds fun. I enjoy labbing buddies. Yeah, me too, man. It's encouraging. This labs look pretty good. We're gonna lock it so I don't mess anything up accidentally, and we'll go ahead and yeah, I'm probably gonna go ahead and shut this down for night, even though they're gonna do a little reading. And I'm gonna try to save it out let me go to... I should be using iTerm. And let me see if I have that repo on here. Lab sync. Oh, this is a cat lab. Oh no, that's something else. I don't know what that is. That must be something. That's interesting. I may goof something up there. All right, so let's see. All right, maybe I did it as this user. Okay, here it is. Good. Okay, so let's try git pull. Okay, I have to update something here. Sure, and continue. All right, I need to fix that. All right, lab is shut down. And now we'll just log out and shut down the VM. And what I'm going to do is upload these repos. Once you pass the written, we can all hit some INE labs and Narvik labs. Most definitely get those numbers 29. You know it, man. And I want to be trading labs with you guys too. So get real familiar with this lab. Let me just put it that way, mentors. Learn it well, because you know we'll be trading labs with each other. Guess where some of my labs are going to come from? This lab from hell. So you know, get comfortable, cozy on up. You two should get to know each other. That's another reason I'm like adding on and on to the lab, because I want to be able to reuse it, you know. All right, we're going to put these packet captures out here in the repo. Yes, get to join us and others. Absolutely, yeah. If Dude Friend passes, you know, in this year, if I pass in, we'll all be out of the gate, man, ready January 1. So it's going to be awesome. Oh, shoot, I'll close that. I'm going to, yeah, let me go ahead and upload this stuff. So packet captures, git add everything, git commit, added ipv6 tunneling, caps, git push. Boom, those are uploaded. And what else we update? Our notes. Yep, notes are updated. That's closed out. We're gonna git add, git commit, updated ipv6, git push. Need to check on Big Ape too, motivate each other. Yeah, man, we need to have, again, we need to come up with some sort of, well, I'll actually be hanging out. We'll be doing a local thing here next week, but yeah, we need to do an end of year kind of meetup for sure. All right, I'm gonna stop this VM. Good thing about this VM, I do have automatic backup turned on in Azure, which is pretty cool. You basically just set a policy, and if it's a Ubuntu, it doesn't really matter. I don't know what crash consistent means. What does that mean? Backup pre-check, last backup status successful, around 2:38. No alerts. Oh, I can do file recovery. That's cool. I knew that, I think. I told it to do a full... Okay, select recovery point. I just want to see what this does here. That's already selected. Download script to browse and recover files from the recovery point. Okay. Unmount the disk after... Oh, so it basically creates a mount point and allows me to... I don't know what crash consistent means, though. Help and support. No, I don't want that. Azure backup. Appears I'll be learning some Azure as well to round out my cloud skills. Yeah, man, it's not a bad idea. It's not too bad. I mean, a lot of the IaaS stuff, infrastructure as a service, is pretty, you know, a lot of aspects of it are very similar to what, you know, people do on premise. Now the Azure native stuff, like the you know, the service fabric and the API manager and the application gateway and some of those other new, you know, services that we didn't traditionally have on-prem, the API, you know, the Azure Resource Manager, being able to use templates to automatically deploy, and the Azure DevOps, which is the CI/CD deployment system. All that is new stuff, but your basic VM stuff is pretty similar. Storage is different. I want to see what crash consistency. This such as to virtually experience a crash. Crash consistency typically happens when the Azure is shut down at the time of backup. Oh, okay, I got you. Ah, that's fine. AWS has been pretty smooth and not that bad. Cloud certs are hot right now. Jack of all trades, you know. Yeah. Yeah, I need to learn a little more about AWS. After I do this project for EVE-NG automated deployment in Azure, I want to do the same thing in AWS. And then I want to do it in Google Cloud, you know. Not just deploy the VM, but actually do an automated deploy. All right, I think we are shut down. Yeah, we're good to go. So that's going to end the stream for tonight. Folks, hit me up on Discord if you haven't joined the Discord yet. Check us out there. We got some new subs today. We had some biddies donated. So yeah, Dimitri's got a man. I want to be Dimitri when I grow up. So bad. Yeah, so we had some good participation in the different lab sessions today. I had 3 sessions today, and that's probably what I'll do. Tomorrow I'll have 1 or 2, and then Monday we'll probably have 2 or 3 lab sessions, because generally I'll do it 2-3 hours, then take a break, get a meal, relax, and then come back for 2-3 hours and blah, blah, blah. And I'll upload the whole thing to YouTube as a single lab session. But anyway, thanks for hanging out. Good to chat with you mentors and others. I know in the stream, been a lot of chats today, which has been great. Good camaraderie, good community, good stuff, good bits to everybody. Can never have enough good bits. So we shall see you all tomorrow. Have a great night and keep hitting it.